Get YouTube going. We're here. All right. Now, this freaking doc. All right, 1 second. Let me get my YouTube chat working. I mean, I have... there has to be a better way to do this, I guess. Because I literally can't do it before I start the stream, unfortunately. There we go. Okay. Think I'm all set. All right, let's get into it. We got a DM. Oh, interesting. Okay. So I recommended them Paul's notes, and they said they already, that's what they were learning from. Okay. Nothing for me to post there. Wait, okay, how do I... This is really annoying. In my OBS chat doc, I'm logged in as my gaming channel. And I would want to be logged in as my actual channel, but I don't see a way to actually accomplish that. So I guess I can go to hell as far as OBS is concerned. Or I think probably more YouTube's fault, but I'm just going to blame everyone who's not me. Make sure the audio loads are okay. I think they are. Go over to homework help. Oh, okay. I think it's already an answer, but you have to pay attention to the axes here. It's cumulative frequency on the vertical axis. Why does it only add to 50? Is the graph truncated? Oh, no. This is the absolute, not percent. Okay. So you just take the point at 6, so 10, I think. Is that a heart or an evil face? Either way, it's not important, but it's kind of funny. Jed? Good to have you there for the real analysis. Pumpkin thighs. Fifth class? What are the numbers in your neighborhood? Oh my god, that's a great pickup line. Oh god, ordinal and interval? Okay, Alkalainer got it. I'm not gonna have to Google. Hey, Storm. Where the heck are the unanswered questions? Probability of fatality. Man, there's not much in homework help. Let's look at Learn Math. Analytic geometry. Oh gosh. Well, I feel like, yeah, you can be symmetric about any point or line. It makes sense to be symmetric around like a triangle, I guess, or a curve. Unless you're talking about curved space or something like that. I feel like if they're taking analytic geometry, they might be at a level beyond me. Just what's written here, Storm. You understand the question, SPQ? I think just like extending the idea of symmetry to be not about the origin or one of the axes. Like we talk about even and odd functions is what's coming to mind. Like if you had like oh god, does this one's I don't know the VPN even turned on, I don't think. Okay, there. I think they want to they're talking about like something like if you have y equals x sine x. No, that's not it. X plus sine x. Oh, actually, I don't think this is actually symmetric, even though it looks like it. But I think they're asking about like, well, no, that's not even a good example either. They're asking about a symmetry other than like even and odd, I think. And having a hard time actually finding an example of one that. I guess you could have maybe a much simpler example is 1 over x minus 1. I guess, okay, that's a really simple example, but you're symmetric around x equals 1 rather than x equals 0. Yeah. How do you prove that it exists there? I think as a translation of oh, sorry, Sir Dudesworth. There's just gonna be a math day for me. Thank you, though. I don't know how you prove. Well, I think you just translate it to be around 0, 0. I don't know if considering other cases is all that. Can there be symmetry regarding a straight line in the form y equals mx plus b? Oh, I'm thinking of a slant asymptote with that question. I mean, a slant asymptote, does that have to imply symmetry, though? I feel like it usually does with a rational function. Let's just look at their example here. 2x squared plus 3x minus 1. Over 2x plus 1. I guess this does have a slant asymptote, but this exact example, well, it's not symmetric about the origin. Okay. see if f is symmetric on a point A, you have to verify if x plus a is equal to minus of x. It's minus x plus a. Okay. So if I were to try that just with the example that I gave with 1 over 1 minus x, or 1 over x minus 1 rather, but just see like how that would work as an example. So that's kind of like the thing that I was like trying to get to that I couldn't. I was gonna like end up skirting around it. Let's see if I can actually make that make sense to me too. So if we have f of x equals 1 over x minus 1, and we want to say that this is symmetric around the points 1 comma 0, we want to check f of x. You were saying plus a. Storm. So let's do plus 1 is equal to 1 over x, and then f of minus x plus 1 is equal to minus 1 over x, which is equal to minus, like that, no negative sign there. Okay. I guess it makes sense. I might have written it slightly bad, or I didn't write it in the exact same way that you did, but I think it's the same idea. Okay. Hey, Pikachu. You can have, or you can certainly have. What is this? Oh, okay. Sorry about that. Oh shoot, before I forget, let me get my phone on the charger. Okay, there. And don't shake phone, please. How to become VIP? I don't know. I've only ever given VIP to my real life friends. You like the pink square? Maybe I'll do like a channel points thing. Like for some amount of channel points, you can get VIP for a month. But I'm just keeping it to be my real life friends for now at least. You have 2.5K? Oh man, there's some people with a lot of channel points though. I was thinking more like 10,000 or something. Which it would take a lot longer for you to get to. I don't know. Maybe I can do it based on saves or something. That's just what I was thinking about, Pikachu. I don't know if I'm gonna actually make or I don't know if I'm gonna do it in the first place, and I don't know if I would make it only 10,000 or what. One over x minus 1 is symmetric around 1 comma 0, or x equals 1. You're gonna redeem it. F of x minus 1 is equal to minus. Well, it depends, because it's like more of an odd symmetry. And then we're saying +1 as well. Yeah, point would be odd symmetry. You're right, Storm. I think what I've written. Oh wait, no. Are you doing analysis right now? Like with this symmetry question? I don't know if this counts as analysis. I guess it's kind of like baby analysis, or I don't know. So I showed is that I guess I showed that is how I wrote it. But I think maybe what Storm put is a bit more clear what's happening. In either way, it's the same. Okay. Symmetry points consider analysis. I don't know. It's making generalizations about functions, which I associate with analysis. All this isn't particularly like... Yeah, SPK, that's why I start off my post with saying, like, I haven't taken analytic geometry, so I'm not sure if there's something that I'm missing, but I figure this, if they're, it feels like the thing they're asking about is really based on marrying it to like, what we're doing in the course and relating it to Cartesian coordinates, I guess. Hey, hoo-hoo, how are you? Consider a circle x1 squared plus x2 squared minus 1 equals 0, or f of x equals that. Well, that's well, that's two-dimensional. Wouldn't that be a sphere? Well, no, if it's f of x, I don't know. I'm really confused by that. You're fine? I'm doing good too. I've got my my tea. Actually just finished it. A 1D sphere. But if there's x1 and x2, aren't those like your x and y and f of x is z? I don't know how you have that many inputs if it's still one-dimensional. Again, so I haven't taken analytic geometry, so I'm like kind of putting this caveat in front. So what's the example that we looked at? 2x squared plus 3x. Two x plus 1. Oh, it was only p. Oh no, it's the entire graph. Okay. And this was symmetric about x plus 1? Yeah. Because they're specifically asking about like symmetric about like a symmetry about a point that's not the origin, and then also about a line in general y equals mx plus b. In R2, it's a one-dimensional sphere. Oh god, okay, yeah. F of x equals 0 and Rn will select an n minus 1 dimensional manifold. Okay, yeah, no, I'm completely lost with that. I think this is all that I'm gonna say though. Because I think this addresses their question they were asking, as I understand it, so. Actually, well, I'm gonna add in one more thing. then 0, 0, or a more convenient, or y equals x is often not discussed, since you can always just translate the function. 1 over x minus 1 is just a translation of 1 over x. Okay, I think that addresses their question. This playlist has a lot of anime music. The last song that was just playing, because I think it just switched. Oh god, I don't know how you pronounce this. Renai Circulation, and then parentheses Bakemonogatari? Oh, who knows that too? Okay, yeah, so this place that has a lot of like, I don't know if it's the original like anime music or like remix or whatever, but it's just kind of chill, so that's why I've been having it on. So, okay. This one I'm pretty sure I can handle. Let me get my let me put my mug away so it doesn't stain. Okay. So their number of trials is 4, their x is 1, and they want greater than or equal to that. And p is 0.5. Yeah, Storm, I agree. Either way, n is 4. Since this is a coin flip, then the probability p is 0.5. And since they're asking for, how do you do italics? Double? No, just single asterisk. At least one tail. We want x greater than or equal to 1. Oh yeah, that's true too, Storm. You can do x equals 0. Calculate the opposite, the probability of no tails, then do 1 minus that to get to the opposite, or to negate the probability. I don't know if negation is the right word, but I'm going to use it. I got a reply. That's for symmetry. I think I kind of understood it. Okay, well, I'll just leave it be then. They're not gonna. If they have a specific question, I would answer it, but I might just need to like read it more or something. Oh, you mean like literally using the binomial theorem to like more prove it? I feel like if they're asking the question like this, I feel like they just mean applying it. I don't know if you mean something a bit more like rigorous though. I think you just have to apply the formula in some way. What I interpreted is he meant this formula. The person who asked it. Because it kind of gets called different things, but binomial theorem, I mean, actually, does binomial theorem refer to like expanding a polynomial, which is still related to this? Because it's actually like literally the exact same formula in different contexts. That's kind of funny. I noticed that these are basically the exact same formula, but I assume they're even more related than that. But yeah, Storm. Or to SPQ's point, I think they said binomial theorem, but they just mean a binomial probability. That's my theory, at least. Because it gets called like binomial probability, binomial distribution, binomial whatever, just something about binomial. If they're wording it in a super like advanced like mathematic way, for lack of a better term, I mean, I might think that they're asking literally about the binomial theorem, but I don't think it's the case, at least. Because we're just asking in general about sharing with algebra and trig and the concept of calculus class. It's a very common thing. I'm just going to give him Paul's online notes because Paula's love, Paula's life. Yeah, I only skimmed the post, but they're really just asking about how to get more practice with trig. Feels dank, man. Yeah. Isn't the same person that I already went to Paul's notes the other day, was it? That was Everyday Bison, and this is someone else. Okay. For integrals with trig functions and trig substitutions. Wait, substitution. Okay, there we go. Got it. You're out of here, Storm? All right. Thanks for hanging out. Hope you sleep well. Hey, Frylock. Not much with me. How about you? With trig functions, what you'll encounter in a normal calculus class will usually use the same few tricks / identities that many students will just memorize. Okay. Constitution and make some amendments. Perfect. The issue is I still have to sound out Constitution though. Oh, I got another DM. Oh, the Symmetry person. Let's give them the site. Example from this site. Oh, that's a big old link. Let's make sure it actually works. Okay, good, it does. Process is you do long division on the function, ignore the remainder, and you end up with x plus 1. Actually, that's... Ooh, they might be asking about like how you prove that, and that I don't know. Yeah, I don't really know how you prove it's symmetric around a line. So I think like if you just have y equals x, the nice case, you use like inverse functions. I don't really know how you do it for like an arbitrary line though. Unless you want to do like translations and what's it called when you stretch or shrink a function? I forget. Scaling, I guess. Let's go over to Ask Math. Oh God. This is the gradient? A vector function. Oh God, I'm not a fan of this formatting. Oh, okay, so those are 3 separate equations for Friedlock that you have to solve? I can help you with those. Let's see. Oh yeah, this is my shiny new eraser, so let's see if it does a better job. It really doesn't. It kind of does. So it's not smudging. Yeah, it's not really smudging. Still takes forever to actually erase it though. Okay, so Stu Green. So Freilich, your first equation is 1 plus s equals 3. And this is just one step. So the goal here is to isolate s and figure out what s actually is. The thing that is preventing us from knowing what it is right now is this 1 over here. It's a positive 1 and we want to get it to the other side. So let's do that by subtracting 1 from each side. So 1 minus 1 becomes 0. So we're just left with s. And then 3 minus 1 is 2. So I'd say that s equals 2. You could also look at the initial equation just as more of a question, like what number plus 1 equals 3, and kind of in a more intuitive way, know that 2 plus 1 equals 3. So that line of thinking works better for some people. For others, they want to just do it this algebra way, but that explanation exists too. You also have 24 equals 4c. And so here, we want c to be alone. The thing that's stopping us from doing that is this 4 being multiplied. And so we undo that multiplication by doing division. So let's divide each side by 4. Here, 4 divided by 4 is just 1. We often say that they cancel, but it's two different ways of saying that 4 divided by 4 is 1. So 1 times c is just c, and then 24 divided by 4, I happen to know that that's 6. So here I'd say that c equals 6. And again, you could have looked at the initial equation and just say, what number times 4 equals 24? And if you are good with your times tables, you know that 6 times 4 is just 24. But either way works here. And your last equation is v over 5 equals 9. So here we're dividing by 5, and you undo division with multiplication. So let's multiply each side by 5. I'm going to do a dot here for multiplication. You might be using, you might be using an x, which I guess I'll actually write. It's completely the same thing. So I'll just use an x because you might be more familiar with that. We'll multiply each side by 5. And then here, we still have 5 basically divided by 5. The multiplication being there is okay, it doesn't affect anything. So these 5's cancel. And then we say v equals 9 times 5, and 9 times 5 is 45. So does that make sense? Right, like I hope I wasn't going too fast. Wait, Jed. 9 times 5 is 45. It's always good to verify. Oh, I see. Okay. You're scaring me that I get into basic math. It does make sense? Okay. And so I'll show what Jed is saying too, that if you're ever unsure about your answer, you can always plug it back into your original equation just to like verify it. So if I think the answer here is 45, we can plug it back into our original one just to make sure. 45 over 5 equals 9. And so here we get 45 divided by 5, that is 9. We get 9 equals 9. That's a true statement, so we know our answer is right. If we got like 0 equals 9 or 1 equals 9, you know, something that isn't right, then you know you did something wrong. No! Please, God, no! Yeah. So yeah, thanks for the question, Frylock. Questions? What's up with this vector function? I'm not a fan of how this is written, but it is written, I guess. I wish I would be more specific about what derivative meant. This looks like a gradient. I don't really know that for sure, though. Oh, actually, they don't have to find the original function. Plus the question in your homework. Oh, okay. It's asking why you get 0 when you plug in pi over 2, but not also pi. So let's verify that pi over 2 thing is right. Cosine of pi over 2 is 0. So you get 0 times -1 it's all multiplication, so everything goes to 0. Whereas over here, you get the same thing, 0, 0. Okay, so yes, that's the 0 vector. When you plug in pi, well, sine of pi is 0. So yeah, I don't know why you would, or why you wouldn't get 0 for that as well. I feel like I don't have the entire question here, so I don't really feel confident answering though. Quasi-potential? I clicked on it because it was tagged as calculus, but this is some advanced calculus. I think I'm gonna pass. Some calculus limits here from Toxic Nasty. Surprised no one answered this. Let's see. All right. It's just verifying their work, it looks like. Gonna play Daisy. All right, sounds good, Frylock. Enjoy. We limit as x approaches 9 of 3x squared minus sine of pi x over 6. Plug in x equals 9. Seems reasonable. 3 times 9 squared is 3 times 83, or 81. 243, that makes sense. Minus sine of 3 pi over 2 is negative 1. Minus negative 1 is plus 1, so I agree with 244. Okay. Now we have this one as x approaches 8. They didn't write the original problem here. Oh, I get it. It's x squared minus 6x minus 16, and they're doing the factoring thing. Okay, that makes sense. Because you can get this will factor, you get an x minus 8 out of this. So you get, or x plus 8. It should be, they both turn into x plus 8s. They should be x minus 8s. It doesn't make a difference. They still get to the right answer. Is the vector function really off? Yeah, Jed. Okay, so for part B, okay, so then for part C, what do we have? 2x minus 1 when x is less than 9, 8 when x equals 9, and x squared plus 2x when x is greater than 9. And we are doing the limit as x approaches 9 from the right, from the left, and in general. So when x approaches 9 from the right, we're talking about starting from greater than 9 and going to the left, ironically, to get closer to 9, because that's what from the right means. So we take this bottom function, 9 squared plus 2 times 9, that's 81 plus 18, that is 99. That looks good. Approaching 9 from the left, we do 3 times 9 is 18, no, 27, minus 1 is 26. Oh, I'm glad to hear that, Frylock. Thank you for the kind words. And it would say that the limit overall does not exist because the limit from the left, or from the left, does not match the limit on the right, so I agree with their conclusion there. Now, we limit the x approaches 0 of root x plus 4, set, I guess, minus 2 over x. They multiply by root x plus 4 plus 2, the conjugate. Which seems like a good idea. Do you just get x in the numerator? It doesn't feel right. Maybe you do. You get x plus 4 minus 4. Yeah, so you do just get x in the numerator. Oh, yes, Jed. It's a good clarification. I'm glad you find the streams helpful. Saves you. Look at the bot. It is awake. So yeah, we get a cancellation with the x's. 1 over x plus 4 plus 2, plug in 0. Now we can do that safely. You get 1 over 4. Yeah, this person's a champ. Used for books in DayZ? I don't think so. Are there even... Like, are you able to physically pick up a book? I don't think that's a thing. Either way, I don't think it's going to have a use. Maybe you can cut it up for paper or something, but I don't remember seeing a book in DayZ. Well, not an actual server. There's a book item in the game files that I've seen, but... Nicely done. According to the wiki? Oh, okay. I've never seen a book actually, like, around, I don't think. I haven't played a straight vanilla server in a very long time, though. So maybe just servers I play take the books out. Oh, they were removed. Okay. I think the DayZ wiki actually isn't that good either, but like it's not necessarily kept up to date. But I would believe that. Because they literally, like, they released the game having issues with the engine, and they recoded the entire game from the ground up. So a lot of things that were in the game got removed and are still waiting to be re-implemented. But I feel like you'd have to actually look through the patch notes to be safe, because I've seen some weird things written in the DayZ wiki. Let's see what this one's about. Hey, Clemens Leahy. How's it going? Sorry, I'm probably not saying that right. This one has an answer. I didn't spot that. It's good to hear, Clemens. I'm doing good too. Thanks for asking. Just looking for the next question to work on. You have discrete math test today. Ooh, good luck. Discrete math was one of the harder classes that I took, so I'm not very good with proofs. Tomorrow? Oh, okay. Let's go over to the math Discord, I think. Sorry, I'm just responding to Discord message, and then I'm gonna bring up the math Discord. Oh, you have to go? All right, Clemens. Thanks for stopping in. Okay. Sounds like a fun time. For Jed, maybe. All right, I'm bringing up the math Discord right now. Okay. I'm kind of curious. What's in their events thing? I see there's a... That was on January 23rd. That didn't show up in my Discord, did it? They don't always hit publish on their events here. Did it show up in my server? I don't know if I even want this problem of the day thing. It's kind of annoying. No, it didn't show up. They didn't hit publish on that. Ugh. I kind of wish they would. Oh, well, okay, that's not important. Pickle my tip? Okay, let's see what this person needs. Given f of x is equal to 2 to the power of 1 over x plus 1 over 1 plus 2 to the power of 1 over x plus 1, and g of x is equal to that, show that xg of x minus g of 1 over x is equal to 0 for all x not equal to 0. Okay, this is weird, but you can do it. Don't know how to do the solving for x. If you put a battery in it, it'll tell you your coordinates. If you have an in-game map, you can turn the GPS on, and when you open up the map, it'll tell you your coordinates on that map view as well. So it should. The GPS is kind of weird. I don't know exactly how it works. I don't always use them. So what's their setup here? This step isn't technically right because it's g, which is a function of, or which includes f in its step definition. This is just f. But over here, I have a hard time following their work. Let's try and work this out the way that I would think to do this by figuring out what g of x is without all the f of x's involved. Very weird function. But I think we're just gonna use some log identities here and we'll be able to get something that's a bit more manageable. Go red. Oh, I did get a new eraser because I had already ordered it, but I also have this old rag that I completely forgot about that I could also use. Well, whiteboard isn't like that bad yet though, right? It does have some smudges on it. I don't know why I'm unwilling to use a rag. I just feel like the eraser should work. Even though it doesn't seem to. Is it 1 plus or minus? Plus. Starting in the middle? I always start in the middle because I'm too lazy to go to the left side. All right, just to make sure I copied it down right. We have g of x to log base 2 f of x over 1 minus f of x. Annoying. Let's work just this problem. Let's figure out what g of x really is. Just like Scooby-Doo. Let's figure out what this function really is. So f of x is equal to that. This is already really annoying. What evil teacher gave their student this problem? What the hell, dude? We can use a bunch of log identities here. So log of a over b is equal to log of a minus log of b. Identity first. You're right, Jed. Let's do things the hard way, though. That's how I always do things. So log base 2 of that minus log base 2 of that. And then we multiply by the reciprocal of that. So I guess we would do plus, oops. That's the log base 2 of the entire thing, because it's going to be a little bit weird. Wait, oh no, the reciprocal of this is so annoying. Okay, it's going to be 1 over one minus 2 to the 1 over x plus 1 over 1 plus 2 to the 1 over x plus 1, like that. Actually, no, I could just do a minus and not do this reciprocal stuff. The outer division first. Like the division inside here, I'm kind of doing it mentally. Instead of making that a plus, we can just make it a minus, because we're dividing by that. Okay, I think we're gonna need a common denominator in there. Well, actually, what's the actual goal? X, g of x minus g of 1 over x. I want to simplify this more. We could do that. I feel like we might, but like for this log over here, I specifically don't want to use a variable like that, because we can use the exponent rule here to bring it down, and log base 2 of 2 is 1. So that's just 1 over x plus 1. Here, though, I think you're stuck. I don't think there's an identity that we can use here. Here, let's get a common denominator. 1 plus... Okay, so the 2's are going to go away. On top, at least. Hey, Anders. Great session today? Yeah, I thought it was really nice. Like, I really like the discussion that we were having. So we get log base 2 of 1, which is 0, minus is plus log base 2, 1 plus 2 to the 1 over x plus 1. Hey, we get minus and plus, so it's equal to 1 over x plus 1. God, all that. They're just making you do a lot of work for no reason. The stream last night? Thank you, Frylock. So now let's set up x. So we know that g of x is this. Now let's set up x g of x minus g of 1 over x. That means x multiplied through that is 1 plus x minus g of 1 over x. That means everywhere we see x, we substitute with 1 over x. 1 over x is just x. X minus x is 0. 1 minus 1 is 0. So yeah, we get 0. Okay. I feel like I can confidently answer this person's question now. What is someone posted something this that I don't want to show on stream? What? Oh, yeah, I'm glad I'm not showing this on stream. I need to do a little add moderators here. Sorry, I'm gonna get back to the person's question. There's something really offensive posted in this thing, not by the original poster, but really glad that I didn't. I guess the audio came through. It was just like music. Okay, it got deleted. Okay. Well, the mods are on it. God, I freaking hate even seeing that. But anyway, it wasn't this person who posted it. Just for clarity, it was a completely random person. How should I phrase it to this person? Should I actually try and type out the LaTeX for this? I think this person, it might help this person. Isn't exactly right. It should be more like g of x equals slash frac, and then we're gonna need fractions inside fractions here. 2 to the, and then brackets again for the exponent, and then another fraction. Oh my gosh. 1, and then I think you need the caret x. I should verify that. Where is my LaTeX? Well, it was to verify an identity, Jed, so the final answer for g of x is 1 over x plus 1. And then it did successfully, like, fit that identity. Oh no, you don't do a caret. Okay, maybe that's for integrals that you do the caret. So that one we don't want. Plus 1? Right. Oh god, this will be better written in an actual editor that will keep track of these brackets. So I can close another one. So that bracket goes with that bracket. So that entire thing was like that. Okay. Now we're in the bottom of the first fraction. 1 plus the same exact thing. Then we need another brackets. I'm going to mess this up. So, Jed, with the end of my statement here, I just got to that. And now I need to do the lower part of the fraction. Should be really similar. I should be able to copy paste if I got my first line right. So this bracket, wait, okay. This bracket comes over here. This bracket comes over here. And then that matches with this bracket, which was this fraction. Did I close this? I think I need to. Wait. That bracket goes there. I probably should. That'd be a good idea. The random website. Oops. Emergency stop? Okay, it wasn't that bad. I mean, this definitely won't work because AK-74 and a hatchet? I love a good AK. Hatchets are fine. It's a melee. Okay. Okay, so I got this part working. Now let's do the other part of the fraction. Oh, I did forget about the log. See. Oh, I didn't know that the bar would work for fractions. Nope. Oh shoot. Does undo work? Okay, it does. I don't know what there's syntax in there that I don't recognize. Okay, now we'll do the outside fraction, and it's the same exact thing, but 1 minus. So we want to copy this bad boy here, close. Good. And then we need the log base 2, which you can do. Just you literally type out log and then where's the subscript? Underscore. There we go. Here's our LaTeX. That is a good call to check in a separate renderer. I guess not. Or maybe it's there's different versions of LaTeX. I don't know. Okay. So let's see, let's give the person some time to work on that. Let's look for a new one. Okay, so we got a rectangle. Oh, what, you messaged me, Jed? Oh, you did work on that problem too? Same as you just did the identity first. Oh, you did the identity on the f of x function? I see, yeah. Let me show it. So yeah, that is a lot less writing if you do the identity with the f of x's first. It gets you to the same answer though. So like it's a matter of preference. I keep, oh my god. I'm glad that I don't like put controversial stuff in my messages because like I'm gonna accidentally like show my DMs one day. I feel like if I'm not being careful. Okay. I'm gonna actually like show something bad. What is happening here? The area of the rectangle is this thing with A's and B's. The length of one side is 2A, 2B. What is the length of the other side of the rectangle of... Oh. What an annoying problem. They're just making you do a lot of work for no reason. So A equals 3, B equals 2. You just have to plug it into the area and then divide by this. So yeah, 20 times 81 times... Wait, 3 to the 4th? Yeah, that's 81. Times 16. Oh wait, there's x's in here? No, that's for multiplication. Yeah, Felix. It's just like, why would you make a student do all this? Oh wait, you're right, Jed. You can factor out an A and a B. You can save yourself a bit of work. You can get some cancellations. You can factor out a 4AB. Can I make Wolfram do this for me? So let's take what they wrote, Wolfram will interpret, right? let's take that and divide everything by 4ab. So that becomes 5 a cubed b cubed. That becomes 2 a squared, and the b goes away because it was b to the 1. Yep. And then we divide... Oh wait, 4 doesn't go into 6, does it? Okay, divided the others by 2. Or multiply those by 2, and then this one comes down to 3. That becomes a cubed b squared. With a equals 3, b equals 2. Hopefully Wolfram Alpha interprets that. $24.48. What did they get? They got 816. One of us said something wrong. Oh, the second term that I wrote? Well, yeah, they had the extra caret there. I think that's just a typo, though. Well, if you look at the actual work, it's just a cubed b. I don't think there's any, like, a to the 3 to the b or anything like that. Why is that 2a? Oh, that's 2a squared b. They wrote 2a to b. There's supposed to be a caret there. So that's why we get different answers. Okay, so instead of dividing by 2ab, actually I would still have to divide. I did. Oh yeah, I the thing that I did was even wrong with the way that I was thinking. We can divide everything by 2a squared b though. Let me copy paste their original one again, because I don't think they typed it out quite right, which is fine. It's hard to type out math. So we can divide each of these terms by 2a squared b. So that becomes 10 a squared b cubed minus 4 a to the 1 and no b, 3 a squared b, no, a to the 1? What was the original power of a? A to the 4th? Yeah, so a squared. 816. That matches what they got. What do you mean, Jed? 7. Yeah, you're supposed to have an a in each term. The a squareds don't completely go away, or an a in each term. You're dividing everything by a squared here. Wait, so I didn't actually show it on the board, but I factored out a 2a squared b. Because, like, the work doesn't show it exactly, but you take this, you divide it by 2a squared b. That saved you a... I did that, like, mentally without wanting to write out every last letter. That comes in sickle, nice. You can save a bit of time if you look at let's fix their work. Over to a squared b, and notice that the 2a squared b can cancel with everything in the numerator, but there's still a lot of calculations to do. I see pickle my tip. It does look complicated for sure. Start with finding the quotient identity. Hey, Hypatia. On the big fraction. How's it going? Wrote a cool thing today. About what? Minus log base 2. I think I have a mismatch. Use my previous window. Oh, I think I deleted that, to be honest. I probably shouldn't have. You on Discord? All right, I'll take a peek at it in a second. Oh no, that's not right. I have one too many fractions. Oh yeah, that's true too, Jed. I did things the hard way though, and it worked out. Would you look at that? Make sure it matches. From there, you can apply the same identity to the first log, then and get a common denominator inside the second log. One could render a syntax tree for LaTeX. Damien, it's definitely like things where you just like hit a symbol for it to like do the LaTeX code for you. If that's what you mean, but I feel like you mean something else. Okay, that person's just saying thanks. So we have a second. Let's see if I can find what you posted, Hypatia. My computer doesn't like. Oh, okay. I was wondering how you or my computer doesn't know what to do with a .asm file. But the brackets thing, it would be nice if it just did those for you. Source code? Oh, okay. A spark plug, you can put it in a car. It's one of the parts that a car needs, for luck. Open with Vim. Like a virtual machine? I don't have any like LaTeX software on my computer. Any text editor? Oh, okay. Just like Notepad. VS Code will do it? Okay. Either way, I'm looking at it now just a Notepad. I Angry Mouse, I don't know what this means. I'm sure it means something. I do have Notepad++ as well, but... I'm looking at the actual file, yeah. You know what? Sometimes even like let me see if Opera can do just like display the text. No, it can't. I don't know Frylock. I don't really plan it out that far in advance. I'm completely unfamiliar with this type of file. So, assembly coding. I did assembly language as well. When I saw ASM, that's what the first thing that I thought. I don't know if ASM meant that in this context or something. Yeah, assembly language is not fun. It's an O1 time function to approximate a 30. Oh, okay. That makes sense. You play TS 100, yeah. I'm still kind of interested in playing TS 100. I just don't know when I'm going to get around to it. Because that could be like, even though assembly language is really annoying, it might be fun to just like go crazy trying to write it in that game. Back am I? Fast inverse square root. Shenzhen IO is also quite nice. Oh, okay. In Quake 3. Oh, wow. DLDTG? I don't remember that. Evil floating point bit level. Oh, level hacking. Oh, that's funny. Zach. It's a free game on IO. Oh, okay, Jed. Thank you so much, Zach. We have more people at your stream died? Oh, no worries. I don't care at all about viewer count. I appreciate the thought. Power outage? Oh, no. Well, I appreciate it. Class dismissed, yeah. So yeah, I was just looking at the Hypatia was mentioning this like algorithm to quickly estimate the inverse square root, like 1 over root x, and apparently on the Wikipedia page, it's like the original source code when it was implemented in Quake 3, with some simplifications made. ChatGPT is great. We want to be some semi-verifiable things that no one's going to look at too closely. Yeah, I agree with that. Well, that's interesting though, Hypatia. Thanks for like sharing that. It's I also don't know what this is doing. I forget what the double greater than is in C. Doesn't it? Oh yeah, it's like a bitwise shift, right? I don't remember how you even do that, but I think that's what they are. Okay, okay. 300 bytes converted into an NFC chip. Okay. Sim files an extremely small L for this function. Oh wow. Well, that's cool. Thanks for sharing. So yeah, before that I was looking at the math Discord. This person hasn't gotten back to me yet. Take log base 2 and divide by 2 and O of 1. Huh. New method approximate. Wow. Quick, I have a new question. Hey, Penn Center. I'm a little confused what's happening. Class this morning was great. I thought the discussion we were having was really like interesting. Oh, and I look forward to seeing what you guys do with the questions. That's something that I like about being in section 1, that I get to like do the questions and then see how you guys interpret things. But of course, then the disadvantage is they get the second draft and we get the first draft of the questions. But you're always good about like clarifying things when we have questions, so it's not really that a big deal. Back over the VODs for you guys. Who's you teaching? Oh yeah. Oh god, interest? I don't remember the formulas. Accidentally played Ocarina of Time last night until 2 a.m. Are you practicing? Gotta get the strats. You know, gotta like shake off the rust. You don't play section 1 until section 2 is over? Oh, no cheating. Controls on 8-bit are tough. Oh, okay. Ugh. I'm kind of lazy to actually do this, but I can. And you might want to. And that's a formula right there. The amount is equal to the principal times 1 plus rate over, oh my god, is n the number of times it compounds? If we're doing it in terms of years, I guess n is 12 and, you know, t equals 1 would be for a year. Does math you can help? Okay, it's just like basic compounding interest. I just never remember the formula offhand. Or like how to interpret it. But I think I sort of part A is just plugging or part A and B is just plugging in t equals 3 and t equals 12 with what they have here nearly. They didn't set the formula right. 0.055, it should be divided by n. I'm gonna open this in a browser so I can like switch back and forth between this and Wolfram. And its number of compounds per year. Okay, good. Glad I interpreted that right. Okay, so let's see what this setup should be for Nuha, which is a name I haven't heard before, but like 12% monthly, you need 12% over 12. Okay, that makes sense. It's going to be 500 times, that's not right. 500 times 1 plus Nua's 500, 5.5 interest quarterly. That's important to know. I didn't even spot that. So 0.055 divided by 4, because as last I checked, there's 4 quarters in a year. To the power of nt, we said? Which is 4 times how many years we're working with? 3 years for part A. $589? That can't be right. It should be, well, maybe that is right. If it's compounding, I feel like it should be higher. It's good to you? Okay. Maybe I just have too much faith in compounding interest. Oh, ask me how to set C up. I'm not even doing the right part of the question. Either way, guys, I've gotten a little more familiar with the Pi. Okay, that's fair, Penn Center. So in track as soon as she has at least $5,000 in this account, how many years will that take? Ooh, okay, gonna have to do some logarithm stuff. So we're gonna do 5,000 equals 4 times x. Just tell me the answer. 42 years? Geez, you're gonna be waiting for a while. That's 8-bit 2 slander. Yeah, dude. The N64 controller is so weird. You need 3 arms. I guess it makes sense. It's going to take a long time. You start with $500 and wait for it to grow to $5,000. So I should go to solve this. You divide each side by 500. Maybe I should just give them the setup and see if they ask a question after that, though, I think. $5,000 equals 500. 1 plus slash frac 0.055 close open over 4 close parentheses exponent open curly brace 4t. $sign. Hey, we're talking about money, so $signs are even more appropriate. Comes from the interest being compounded quarterly. So 4 times per year. Okay. See, did it render right? Hey, I did LaTeX right. It's a very nice controller. If you could change the inverted controls, you'd be happy with the port. Yeah, that'd be annoying. The math Discord is popping today. Like, look at all these threads. Apparently the streamers are slacking, including me. School back in session? Yeah. -2 times 4 equals 8. That seems reasonable. I wish... What question are they asking about? Is this calculus or is this like... So I'm seeing gradient. Oh, that just means slope. Okay. I saw gradient and I was like, oh, multivariable calculus. But no, they're not doing the exciting gradient. More specifically, the substitution bit. Tom got so excited. Honestly, I get a little bit nervous too because I don't remember it well enough. But I think multivariable calculus is really fun. I've just gotten a little bit too rusty. Calc 1 and not American. So what part? I think they're talking about this part, maybe? Perpendicular. Oh my god. Ah, that's not even standard form. I hate it. Pass through the point 4, -2. Okay, it's still like the gradient. It's just when I learned it, we never called it that until we got to multivariable calc. Could have been so proud to be solving a D. Oh yeah, you mentioned that Storm's helping you with the D, right? Actually, I might have seen the post in your Discord too. Okay, you got me curious now. So it looked like a fun one. Yeah, I like point slope too. Or, well, no, I do y equals mx plus b. Point slope is good though too. Wait, I remember seeing it. I didn't, like, ooh, that looks like a fun differential equation. Oh, it was, oh wait, I saw this one and thought it looked fun. But you were doing like a system of differential equations. I know, I guess that was a different one, but that's even more fun. That was the favorite, that was my favorite thing that I ever did when I was studying. And I kind of remember how to do it, but I don't remember it well enough. It's a lot of work. You have to get the eigenvectors and the eigenvalues. And then there's like a format that you plug things into for the solution. It was wild but fun, yeah. And you get such cool graphs too. If you graph out like the vector field. Like it can like sink into one point like a spiral galaxy, or it could like flow around like some kind of pool in a hotel. That's Prince is already on. Eigenvalues tell you source/sink. Oh yeah, source and sink were like the terms. Paul's notes has a section on those as well, like the systems of differential equations. Dynamical systems? Oh, is that what that's called? I didn't learn it by name. The class that I learned it in is called literally, the major is applied math, and the class was methods of applied mathematics. So like we didn't. I didn't connect it with an overall area. Get saddles asking for a friend. Opposite signs. That makes sense. Yeah, you can do like you can model like predator prey like systems with those where as the population of the prey increases, the predators increase too, and then it levels off, and then it like drops down, and it goes to like cycles. I thought it was really cool. Locke Volterra? You teach it in Calc 2? Really? I remember that name. I need to see. I think that's how I learned it. I learned it by that name too. But I think I would have learned it not. I definitely did not learn this in Calc 2. What is this website? Mathematical biology. Yeah, see, it's a system of differential equations. You were fine, Penn Center. Yeah, like I think that these are cool. Talk about an intro to D's. Intro to D's. At a graduate. Oh, at a graduate level though. It's like if this is my introduction to differential equations, I would be complete for undergrads. Intro to D's. Intro to D's nuts. That's a save, Obi. Oh no, the bot's asleep. Oh no, okay, the bot's here. You know, if you want to make me laugh, just tell a poop joke or a fart joke or a decent nuts joke. It's not supposed to happen in Calc 2, but you do it anyway. No, I think that's great. Like, if they, like, you can be like, you know, you don't need to know how this works, but this is an application of what we're doing. It's something that you can, we're seeing Mr. Rogers, yeah. Minor in biology, something in ecology. Oh, interesting. Was I still looking at this one? No, I moved on because I got bored with that one, or I didn't understand what's going on, or someone else was doing it. Implicit differentiation here. This looks valid. What? Oh, no, 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 no. Don't say x squared y squared equals 0. Well, I guess x or y have to equal 0. I wouldn't. Ooh, I don't like that though. That you go from this to this. Is it valid though? Can I think of justification? For why that might be okay? Because I guess x or y has to be 0 there. I guess you're eliminating those. It was good, Fry. Mostly just I woke up, I did Zach's real analysis class, and then I'm here now, so. She has twerking cashews? Oh, that's funny. So I think it's valid if you're not worried about x equals 0 or y equals 0, but I think you shouldn't do that last step. Well, maybe it doesn't eliminate x equals 0, y equals 0. Favorite food? Pan-fried potatoes, so they're nice and crispy with onions. first step or your second step. Well, no, hash browns, it depends how you define hash browns. But I think of hash browns as shredded potatoes, which are also delicious and I love. But my favorite is when you cut them into little like wedges. Oh, what, do you want me to say like kale with a light olive oil dressing with avocado? Oh, or avocado toast, even better. Organic. Fun doesn't do stereotypes. Fun does stereotypes would be an interesting channel. I don't know how long it will last on Twitch, but some definition of interesting. Wow, Mercedes-Benz needs help with math? Is that how they do their engineering? Oh yeah, it turns out that Louis' game crashed and he got stuck in queue. But it was nice while it lasted. The big omega of that? I don't even know. I never learned big O, big omega, all that stuff. I've seen it and I kind of know what it means, but I don't know how you get it. Nauru toes? Oh, here's Mercedes-Benz again. How long have I've been going for nearly 2 hours. I may switch over to do some real analysis. Because in typical fashion, the math Discord is a little bit wacky. Well, okay, wait, what's this? In terms of linear regression, what is the difference between a confidence and a prediction interval? I don't remember if I ever learned about prediction intervals. Let's see if we can figure out what this is. Oh yeah, Jed, that's like the part of big O notation that I do know, which is that like, you know, an algorithm can be like big O of n squared or something. So if you have a list that's like n long, it'll take n squared time to compute. I don't actually find n squared for a given algorithm or stuff like that. And I don't even know the first thing about big theta. Have a regression equation and a known x, you're making a range for your predicted y. And it's different from a confidence interval only in the context that we talk about it, because you call a confidence interval like nearly the same thing. I guess there's an extra 1 plus in this formula. A range for the slope. Really? For the, maybe I should, oh wait, actually, kind of, there might be a key in the heading here for the mean value of y versus the individual y. So I think you're right. Dan, I just need to figure out like what the mean value of y part, try and put it in their terms. Sorry, like a truck drove by and like shook my house. The mean value of y in linear regression. Oh. Oh, okay, so the confidence interval is across all of the y points, trying to find the mean for them, which would help you find the slope, I think. And then a prediction interval is for an individual y. As basically as Dan said. I just need to like figure it out for myself, I guess. How close a y is going to be to a given x. Okay, I think I feel comfortable enough to write an answer here. Extension for linear regression. Yeah, the question is like that's about a confidence interval versus a prediction interval, and I think I know the difference here. I think confidence intervals predict the mean value of y. So all the points and a prediction. They say that English isn't the first language, so I should try to not use anything too fancy. And a prediction interval predicts an individual value of y for a given x. So just 1 point. I think. I thought I saw a new post in here, but maybe it got deleted. When regression or some witchcraft is redundant. No clue. Actually, let's go back to the top of the list where there's fresh questions. Now this is just one step, which makes me even though it's just one step, I get even more nervous that I'm going to mess something up. But regression, witchcraft, and tautology? I think so. You're not proud of that fact? Then minus 19. Regarding big O of n notation, you have to calculate one thing per element. It's of order n. You need to do m calculations for each element, and it's of n squared order. M times n calculations precisely, but we only care about order. Huh. free element doubles the number of prior coefficients of order 2 to the n. Yeah, that's interesting. Okay. And you too, Frylock. It's nice knowing you all. What do we have here? Oh gosh. This is translating math language? I want to see what this one is. I don't know if I'll be able to do it. Let's take a closer look though. Doing too much data analytics and not enough pure maths. Okay, this problem looks kind of interesting. Select. Okay. Oh my god. Wait, is this first statement even related here? A data analyst's job if you chat. Well, hey, unemployed. Do I get to live in Canada? That sounds pretty cool. So I'm going to order n log n, which are good. It would optimize to log n. We knew what to look for optimally. Oh, okay. To move here? I mean, to me, that sounds cool. Imagine being employed, Bob. I know. Why do people even have jobs? Like, just don't have a job. You know, I don't get why all these people are, you know, working jobs. Be an eternal student, yeah. Okay, so the first statement is related here. I'm getting a headache just looking at this. I don't know if I'll actually do this one, but oh, it's the Tokyo Ghoul song again? Unravel. Yeah. Is there stars somewhere here? There's quotes. I don't see the star, but there's also a million symbols here, so I believe that I missed it. They do have there exists a unique thing there. Or CubeTube. So is the output of n true or false, I guess? Same with g and n. For all x, there exists a unique y such that x greater than y implies m of xy or n of x. Oh god. Oh, there wasn't a star? Okay. I feel like I've only seen it very rarely. The EX clam. Okay, so this actually isn't that bad if you can get through the mess of notation. For all x, there exists a unique y such that if x is greater than y, then B is the one that says unique. For the translation? Oh, that makes it a little too easy. Oh my god, Bob, I think you're right. But no, exactly one Y. D also has exactly one. It doesn't say unique, but decide between B and D. That is a good catch, though. They're both false, so we actually don't have to worry about trying to prove or disprove the statement. Such that x minus a y... Oh my god, they write it so weirdly. If x is greater than y, then x minus a y is greater than 0. Or x is less than 0. That seems okay. But no, D also says exactly 1y, so we have to look at D. It is true that for all x... No, no, no. Oh yeah, D is backwards. Okay, well that's not that bad. It's saying for exactly 1y works for all x, but it's for all x there is a y each. Okay. It is B, but we had to eliminate D. Did this already move on? Or am I in the wrong channel? What channel was this in? I never switch off. Did they delete their thing? Oh, they deleted their original message. Okay. All right, if this person wants to jump in and do these, I'll let them do it. Rather backwards, such that epsilon. Oh, is that how you say it's such that? When we were doing the real analysis class, I'm trying to remember what the symbol is for such that. So I'm just writing ST. I forgot, but yeah, it's the backwards epsilon. Found a tundra. Nice, Freyluck. So, no, Freyluck was talking about Daisy. The tundra has a gun. This picture looked like something else to me for a split second. I'm glad it's not what I thought it was gonna be. Shows where my mind is. Yeah, Dan, a laser gun. Hey, Malcolm. All right, see you, Bob. Dude, it's late for you, yeah. Ready to get banned from Twitch? Yeah. Dude, I've had to draw some suspect stuff on my whiteboard to solve geometry problems. Like, oh, there's two circles side by side. And we had to put the centers on the circles. Early in stream, the crazy integral. So the value of the integral was complex. Penile. What's even happening here? I kind of half... No, I have like a quarter remember circuits. No, I don't remember this. Replacement of F? Oh. Let's go back. Okay. Is that the projectile? Yeah. Okay. I was trying to figure out what that was for a minute, but yeah, I guess that's what the gun shoots. Such a small child. I like it. Rotate. There's no phallic sequences in real analysis. What's a phallic sequence of numbers? Like there has to be one of them, right? I don't know. Dropped in to say hi. No worries, Malcolm. Homemade pizza with homemade dough. Nice. Oh, dude, that's so good. If you need to go, then go. But if you're around for a second, is it like pan pizza, or is it like, do you have a pizza stone and you can do like the thin crust, or like what kind of crust we working with? Okay, you know, I have a better way than just giving myself scoliosis. Inspect. I do it in this one. Transform. Hey, transform. Okay, rotate 270 degrees. Okay, there we go. We got there eventually. Oh, what? Excuse me. Opera. Bad. Oh my god. Okay. Gonna be between thin and pan. Oh, okay. That sounds delicious. Okay, freaking opera, man. I just want to see what style of question is and see if Paul's notes has a relevant section. AP calculus AB, yeah. The average velocity. So this is the average value formula there. This one looks like there's some fundamental theorem calculus stuff. Solve the initial value problem. I'm just linking to Paul's online notes in general. Because asking for like problems like this but harder. Saute some mushrooms and onion and pepperoni. Oh my god. You're making me hungry. Honestly, like the best pepperoni is the type that like curls up into a little cup and it gets slightly burnt. If the pepperoni's like that, I'm in heaven. Piazza crust from back in the 80s. Never had to use. I haven't heard of that. But any pepperoni is good pepperoni. But anytime I think about pepperoni, I think of like the slightly burnt, like cup kind. Oh no, yeah. All right, let's spread the good word of Paul to this person. So far, it's save you a slice. Yeah. Come on, it's just like a 6-hour drive or something. SoCal to NorCal. Crackery rather than bready, really? Cup and char pepperoni. Oh, that's a nice way to say it, yeah. Guys here, I don't think it'd be worth it. Yeah. It's good, but not that good. I mean, you don't know how far I'd go for pizza. Pizza's great. Play God of War? I have not. I'm interested in playing it one day, but it's not like that high on my list. Oh God. That... Hey Beppy. Yeah, I definitely am. How about you? Okay, technically that breaks. I mean, it doesn't. I need to write my rules more specifically because that should break the rules. I don't know if it actually does though. Buddha kind of made a similar point because Buddha gave me like a 4x4 matrix to multiply with another 4x4 matrix, and technically they were all like single digit, I think. There's a trick for that. Oh yeah, the difference of two squares is always a set number, or it's always like there's a formula for this. Okay. This isn't gonna be that quick, but let me just remember what this is. It's n+1 or something, right? That and tacos? Oh, yeah. Okay. Let me just remember this trick. So I do know the trick that Zach's problem involves. Oh my god. Okay. After this, I'm going to use the spray bottle, but if you have n+1 squared minus n squared, you can factor that out. N squared plus 2n plus 1 minus n squared. That's the trick. And you get 2n plus 1. In our case, n equals 12. So the answer is 25, I think. Oh, you just factor it as the difference of two squares. That too. Oh, yeah, Anders, for literally every single Discord server besides mine, I right click and I mute server until I turn it back on. And for depending on how much they do, oh shoot, I'm not even showing my Discord. Yeah, for literally every single server besides mine, I do mute server until I turn it back on. And if they do at everyone a lot, I'll do suppress at everyone. You're in the middle of muting your neighbor's TVs. Dude, if only. I think I addressed everyone. I just have a notification in my Discord, but let me depending on server is mine. Oh, okay. Let me look at what this person is asking me, and then I'll look at that. So yeah, if you like at me directly, I'll still like see even in a muted server. But if it's just like at everyone or something, then well, depending on the server, I'll keep it turned on. Like there's one in here that I didn't turn it off for, I guess. It's log base 1 plus 0.055 over 4 of that equals 4t. Actually, I have everyone turned on for yours still, Pen Center. I don't think I turned it off for any of the math discords. So I still like whenever you go live, I'll just like clear that notification manually. The number of contiguous states in the United States plus the number of keys on a standard piano? Is that 48 plus 88? I think it's 88 keys on a piano. I don't know if I'm allowed to Google that. Let me to make sure the formatting is okay. The equation is tag at everyone and Don. Yeah, just make the bot tag me directly just to mess with me. That'd be really funny, honestly. Ugh. God, I have to do LaTeX. Wait. Oh yeah, I do want curly braces there. All right, see you, Malcolm. Log base that of /frac 5,000 over 500. Dollar sign. Oh wait, equals 4t. Hopefully that renders. Oh no, parentheses. Where the heck they go there? Yeah, so basically America without Alaska or Hawaii. Okay. Well, I'm gonna Google the number of keys on a piano. And if you think that's cheating, then sue me. $88! I actually knew that. So 88 plus 48. That's 120 plus 16 is 136. Let me make sure I did the basic math right. 136, heck yeah. I'm taking I'm taking those coffee beans. Oh, the Kirby emotes. Dude, that's so good. They really got the movement well in that emote. The greatest common divisor of white keys on a piano, black keys on a piano. So 52 and 36. I'll allow it. If it's least common multiple, there could be some really mean ones, but GCD of 52 and 36, and you even kindly put it in chat too. Well, 52 divided by 2, it's definitely a number. 20, 26. 26. Wait, does 4 go to 4 goes into 52? Oh, okay. I think the answer is 4. Yeah, the answer is 4. Unconfidently. Yeah, okay, good. It's more like maybe there's like complex solutions too. Actually, there probably aren't, but let's see what this pin is. Me right now? Oh, when I was leaning. Okay, how long have I been going? 2.5 hours? I could look for more things on this Discord, or I don't think there's anyone who's waiting on me. Why there is no lowest common divisor. Well, I guess the lowest common divisor is 1, I guess, so why bother thinking about it? No, Anders, I like it. Yeah, I think let's do some real analysis. Let me bring it up. One more? The latest iPhone major version times the last 2 digits of your Legend of Zelda Tears of the Kingdom was released. Tears of the Kingdom, I think, was last year, which would make it 23. Then the latest iPhone major version. Oh, are they on 15? I do need to Google this and have my same, you know, if you don't like it, then sue me. iPhone. I'm sure that'll make it come up. 15. It's only $1,000. All right, so we got 15. Oh, I guess that's right. Ten out of 10 IGN, of course, as is tradition. 23. I even knew them. 23 times 15. Now. Oh wait. It is fit 15. Okay, okay. So 15 times 23. iOS is 17. Oh, okay. That's funny. I guess because iOS came out, like the iPod Touch came out before the iPhone, maybe? I don't know. So 15 times 23, that's like 15 times 20 is 300? Plus 3 times 15 is 45, so 345? $345, okay. I'm not that bad at mental math. Favorite time in history? QED. Oh, in Penn Center, favorite prime number? I feel like your favorite prime number is 17, and then the integer before 2, so that's just 17. 17 times 1. I presume I associate 17 with Ulysses. Okay, yeah, so you brought it up. It's, I think in one of the real analysis classes, like, well, that's a weird number to bring up. I guess he must like 17. Yeah, favorite time in history? I don't even know. I guess the present. Appreciate what you have. I feel like any time in history, you can always say there's bad things happening, I guess, so. Because you were a dealer? No. I assume you mean cards, but my mind at first went to drugs. Okay. Roulette, I mean roulette. Wait, if you don't deal anything in roulette though, you just spin the thing, don't you? You need a better cover-up story, Penn Center. Oh, that's good. Dealing drugs at the roulette table? Yeah. What drug you got depends on what the roulette table spun, you know? The roulette table has like, you know, weed, crack, meth, whatever. Oh, God. Oh, what's even happening? Okay. Cindy, I always wanted to make the joke when you cross into the USA, but you're afraid. Probably for the better. Okay, so I'm gonna look at real analysis stuff, but I think I'm not gonna look at the real analysis stuff from today. At least not right now. So if you're gonna be watching, or if you're gonna be in section 2, I'm not gonna spoil anything, at least right now. And if anyone in the real analysis class wants to like hop on and talk about something, please do. I don't know. There was something on the last one that I wanted Multiple of 35, since we're impressing you the multiples. How far did you go? Because you can calculate them not too bad, like 35, 70, 105, 140, 175, 110, 210, 245. Oh God. 280, 315. Oh, there's a pattern. It's the same thing, but you just increase the tens by 1 each time. Oh, you were just doing the mental math? Okay. Of all possible chemical substances, turning effectively innumerable. Okay, so I saw on Tuesday's problem set there's this revisit prompt 6-5, and I never did that. So let's see what prompt 6-5 is. If I something this. This was more or less building up to Bolzano wire stress. What is a roulette? Various types of wine. You know what? This is actually interesting to revisit in the context of today's class. This connects back really well, actually. So I feel like I kind of are like we've already kind of covered this, so maybe I want to go back even further. I feel like I'm kind of good with this. Because there's definitely some of the earlier ones that I just never even looked at again. I could try to reprove some of these things, like the sandwich theorem. I don't quite remember how we did that. One, I don't quite remember how we did that. Do you ever just have a class where you walk away and are so fucking soaked for the rest of the day? Today was a fun teaching one. Ooh, that's awesome. I kind of had that from like a good stream day. Like I feel really like amped up after I hit end stream. You know what? Actually, what I want to do, I want to revisit Cauchy implying convergent. That's what I want to do. I was looking at some proof last semester in math that I want to look at again. Probably this site. Actually, no, I was going off on this site. Let me find a different proof, because they were confusing me with their letters. Yeah, this is kind of ugly. To do row reductions for Euclid algorithm. Really? I guess it makes sense that you could that would like fit in with Euclid or the Euclidean algorithm or whatever it's called. The California independence flag? Oh, well. I'm not just some rebel, but it's it's from the game Fallout New Vegas. There's a faction in this game called the New California Republic. It's like a post-apocalyptic game. It's a two-headed bear because everything is like radioactive and animals mutated. There's even a two-headed bear in the game, though? I don't think there is. You have these giant mutated bears. I think they only have one head, though. Cowboys Independent probably get political asylum there faster. There's apparently like a movement to like split California in half or something like that. There's some weird people who like do things with California, but I don't think anything's gonna actually happen. Diagolon? I'd never heard of that, no. So let's just, I kind of like this, just going to use the definition of a Cauchy sequence, because I've heard the term Cauchy sequence before, but I never had to work with one until this real analysis class, so I do want to look through these. Show that sequence 1 over n is Cauchy. Okay, Bob mentioned the Archimedean property before, and I need to remind myself what that is. I know we haven't, property. The states from Florida up to the Dakotas, adding in like BC and Alberta, making a new country. A guy in Canada was arrested for making the joke? Oh, that's super weird. Okay, ordered field F. I'm okay. There exists a natural number greater than x. That's the situation, or that's the explanation that I wanted. X is a real number. There's a natural number greater than x. Okay. I assume the 2 is going to come up later in the proof for why that's important. Oh, because we're going to add these two individual terms. Okay. Suppose n comma m greater than n. Cauchy, yep. So we have x sub n minus x sub m is equal to 1 over n minus 1 over m is less than, with triangle inequality, those two. So n comma m are greater than or equal to n, which is how we're able to justify this statement here, 2 over n, because we're adding two of the same form of number together. And 2 over n, as I said, okay, or as I thought, was chosen to give us this nice property where we can say that these two are less than epsilon. Okay. Well, we say that this original thing is less than epsilon. Ocean surfing? Oh, that's where you were going with that. All right, so 1.4, let x sub n be a sequence of real numbers to find y sub n equal to the sum of x sub n. Oh, series. Let's not look at a series. We haven't even touched series yet, so if we ever will, I don't know. Either way, we haven't dealt with them, so let's not look at series. Blankets are always bounded by epsilon. Ugh. This relationship seems a little arbitrary. I can't even highlight it right, but this like inequality seems arbitrary, but I think it's the point of the problem that you're just given something. So show that x sub n is a Cauchy sequence. What the hell? So n greater than m, you do minus x sub n plus 1 plus x sub n plus 1 all the way down to... Okay, I guess let's see what's happening here. Now, how we're going to use it. It's the finite sum of a geometric series. Oh, we do have a formula for that. Okay, yeah. You're on the Cauchy. Dan, I honestly thought it was Cauchy. Like, I knew it wasn't... I knew that Cauchy wasn't right, but I thought that's how English speakers said it, but... It is Cauchy? Everyone else is just gaslighting us? You know, I prefer your explanation. Because I also taught that C is Kasai, but the entire world disagrees with me. I think this site, I've done it before, I pronounce it C. Where is it? Here. No, wait, that's psi. Wait, then what's psi? Psi, wait, what the hell? They're the same thing. Okay, well, this site is on its own thing. Sorry, I'm going off on a tangent. Actually, that's fine. It's not important. Geometric progression identity. Oh, they factor out a 1/2 to the m to make it end in 1, so it fits the formula? It seems, or gives a cleaner formula. Maybe it wasn't actually necessary. To see? That one I haven't heard. Oh, Google Translate. Okay. She sells seashells by the seashore. But like this. See. Sounds like a dictator. Seashells by the seashore, yeah. Oh, that's where we're going with that. I didn't capitalize the C in Cauchy. It's not cool. So they say that Cauchy sequences. Oh no. It's getting out of hand. Cauchy sequence. Okay, so they say that this geometric progression is convergent and hence Cauchy. So there exists this thing, sure, which we're going to use over here, probably. We have this, which was less than or equal to this, which is equal to this. Is less than epsilon over 2 is less than epsilon. Now, I feel like I understand the individual steps because I went through it like very slowly, but I don't understand the overall. I guess just the point was engineering a situation where you get two terms less than epsilon. Okay. There's a lot of steps to get from, you know, point A to point B. Okay. Oh, so you improve convergence or divergence with Cauchy. I mean, that makes complete sense, but let's see how this example works. Consider the subsequences taking every, okay, 2n pi term, which forces cosine to be 1. In the 4n plus 1 terms, which I guess force it to be pi over 2. Shouldn't they? I feel like they should have written that a little bit differently, so n is still in there. But it's basically this plus pi over 2, which forces cosine to be at the 90 degrees, like pi over 2 thing. So that's 0. If for all n, it's greater than or equal to a given number, I guess? Okay. Following with this negation. So we have to name, you have to be clever in naming subsequences. So we take x sub n squared, which is just n, and we take x sub 4n squared, which is 2n, which are basically two lines getting farther apart. So no matter what your n is, it's always going to be greater than or equal to 1. Okay, kind of on board with that. Actually, they've already taken for granted in this that Cauchy implies convergence. That's really what I wanted to see. Vegans, I'm doing good. How about you? This is what I want to see. Doing good as well. It's good to hear. I was looking at some real analysis stuff from Zach's class, because I've been doing like the homework help for a little bit. But if you or anyone has a question, please like sitting in a math test last few days which you don't know how to solve. I remember having issues trying to solve the last question you asked. If you want to show it, maybe I can figure it out, or maybe someone in chat can. You get so close to the solution. Herbert's here to hang out too, that's completely fine. It's easier than last time? Okay. So yeah, feel free to post it if you want. Yeah, we can at least try. We won't leave you worse off, hopefully. Yeah, take your time, vegans. Or in some globe. I'm just going to take that as an interval. And that globe is a more generalized interval for higher dimensions, like a ball. I think it's a more advanced version of it, but well, they don't say what one is, do they? But I assume it's by the definition of... Oh, wait. That's one. Definition of a Cauchy sequence. I want a simpler explanation. Oh, yeah. I'm trying to remember how... when I was learning... How would they pronounce it? I think there's a mix. Some professors said C, some professors said psi. Same with phi and phi. Phi, phi, pho, fum. Koji's insight was construct R out of Q if we had time. Posted it? Oh, let's see. Or let's sigh, maybe. There's that. There's that. We'll put into Google Translate if we have to. Go away, go away. Go away. So let's see. Conservative in a function sign. Oh no, don't worry at all. Oh. Yeah, let's let Google Translate. Interpolation. Oh gosh. Okay, this looks. Let's see what Google Translate has to say for this. I think I'm gonna need it. Images. Paste. Excuse me. Copy. Paste. Oh my god. Tell you how far you've come? Yeah, sure. I guess save image as. Or not. It's cool. Oh. 1 second. Because the copy paste thing isn't working. Sihi means soul. Oh, it's translating into Greek. We got Google Translate did its best to translate this, Spanish into Greek. What a hero. Oh, pissy? Pissy? Okay, so the reference values in the table above belong to the function that. Nice, Freylock. Derive the upper bound for the maximum error. Oh, you're doing error stuff by explaining the extreme limit of 2 on the interval. Oh god, this actually has Yasai, Yasi, see? This reminds me a bit of Newton's method, or something like that. like Newton-Raphson. Like this form of a formula. Lagrange. Okay. So the actual question, or the question is that you're trying to get the to Newton polynomial. Okay. Are you supposed to get 8 pi to the 4 or pi to the 4 over 576 for this one? Or is this a separate question and the actual question is like down there? Second picture? Yeah, sure. You do derivative of f, right? Here it's n plus 1 to the 4th. Okay. Because we're given p sub 3. Do the max of it. Divided by 4 factorial. The rest you have no clue. 4 factorial is 24. Are we expecting this to be the final answer? You're saying that the 8 pi to the 4 is what you get for the 4th derivative? Roughly? Okay. Oh, that's roughly what you get. Okay, and so what is the we were just talking about this letter, how this Greek letter has like a million different pronunciations, but I'm just gonna call it C. Does C have multiple, does it have all these values? You have to plug them all in, or do you just choose one of these? I think you just choose one. In this case, you're given that there's the maximum at 2. Oh wait, there's an extremum. Oh, the Google Translate wasn't doing a good job with this. Or the function is max. X or the function is max. Okay. I guess this is supposed to approximate our original function. And we use the extremum of this. Okay. Oh, I see. You just posted another one. Let's look at this one. Oh, if we're using this table, maybe we just say it's x equal a third, wherever the highest, or I guess x equal half. That's the highest value. Then why is the polynomial, like, why were we given this? X times x minus a half. It doesn't match points like these. It comes at 0.25. Because you would get 2x minus a half. Right, 0.25. I agree that the max of this happens at x equal 0.25, yeah. What's weird to me is that the chart that's up here, oh, that is oh no, 0.25 is just a half there, which is kind of weird. I don't know if I luck. I just go as long as I feel like. Probably another 2 hours or so. And it's weird, like this little chart here, the maximum isn't at 0.25, but maybe I should ignore that. Maybe I should get this translated too, just see if that helps me at all. Really? Come on, Google. You can do it. Oh, okay. Oh, Google works on that. I see. So we're doing polynomial interpretation with a couple of given points along the function. Let me figure what's happening with this translation though. There we go. Piece of 4. I thought this piece was piece of 4. Oh, okay, that's what they're doing. They did plus px to the other side. I want to see if I can find a different one that's also similar. So I'm still confused by the C here. So our interpolating polynomial is the x times x minus a half. But I think this is like our equivalent thing. Oh, so we don't know where C is. Okay. Each error over the range, multiply those together. What is this max thing? It's kind of weird. Max of the function in the given interval. Okay. It's the actual value where the max happens between 1 and 1.6. It might just be, since it's exponential, I'd expect it to be 1.6. We can just see if I am understanding that right. 8 times e to the 2 times 1.6. What does that come out to be? 196. Okay, good. So the maximum of this over the same interval. Okay, the notation's a little bit confusing to me, but I guess that's what that means. When x goes from 1 to 1.6. And that's n plus 1 factorial. Okay, so maybe I can follow along these steps. Okay, so we need to get the fourth derivative. Okay. So it has to be done for both the functions. Okay, yeah, so they did say, like, you can do the other part with 2 points. Or rather, oh, you think it must be done with both the fx and this thing here? That's what you mean with both functions? Shoot. I don't, with a stream that I don't know what you said yes to. Anyway, let's get the whiteboard cleared off. Yes to the bottom two? Okay, okay. Okay, so oops. I assume it's gonna be easier to work with the version of f of x without the power. So let's say f of x is 1/2 1 minus cosine 2 pi x. And then we say that p sub 3. Yeah, if you just want to say it, that'll make life a bit easier. minus 8 pi to the fourth. Oops, shoot. Sorry for the camera shake. Oh god, I'm making it worse by trying to fix it. Okay. Minus 8 pi to the fourth. That makes sense because 1/2 and you have 4 2's come out. If you derive cosine 4 times, it's sine, yeah, okay. That fourth derivative makes sense to me. And the maximum of this over the interval 0 1/2. I expect cosine to be at a max at 0. Well, it goes from cosine of 0 to cosine of pi. So yeah, I think our max is going to be at 0. Then it's the absolute value of this. So either way, the maximum is 1. It's either 1 or negative 1. Well, 1 times 8 pi to the fourth. So the second exchange thing does do the absolute value of it, but either way, I guess it doesn't matter because you need the actual value of the function. But yeah, over this interval, cosine is just 1 or negative 1. So you just end up with 8 pi to the fourth if you take the absolute value. And then you need to find the maximum at x equals 0.5 is negative 1. Yeah, and x equals, yeah. Oh, okay, I mean, yeah, that works too. I was just going with the stack exchange thread, which uses the absolute value, so either way, it doesn't matter if you take 0 or 1/2, you still get 1. Because I think you need the actual value of the function, that's 8 pi to the fourth. So I think we got to the same thing there. And then they did the maximum error. Right, vegans. I agree with that. Yes, we still have to multiply by the we do the x. Yes. Okay. (24), that's pi to the fourth over 3. And so our x of the points that were given are 0, a quarter. I think I'm using the right points here, just from the table at the start. Okay. So this one is a little bit annoying to derive and set equal to 0. We can do it though. But nah, should we just Wolfram Alpha this? Let's Wolfram Alpha. So I don't want to make a mistake on this part. And yo. Let's go a step further, make Wolfram Alpha do the derivative for us. Okay. Actually, now that I think about it, let's just look at it in Desmos. Innovation that excites here. Are you talking about my stream or like a surf thing or what? Oh, to this? This is the derivative. Well, I guess, yeah, we can just look at this and know. So we're between 0 and a half. So we have extrema, we have 3 extrema. Oh, we're saying that we're expecting like 1 over 24? But there's still, there's the 8 in the numerator though, so it's 576 divided by 3. Purpose side 1 over 24 is restricted? Oh, like this part. Okay. So I want to zoom and enhance a bit here because I just want to see if visually we can know what we are going to expect for the max. Cook. Should be max for 0.5. It might be. We definitely need to check the endpoints. Oh, you get irrational? Why are there only 2 real solutions? So clearly 3 real solutions. I wonder what happens if I give it... Oops. Wolfram Alpha, is Wolfram Alpha this smart? Would it just tell me? We get a maximum according to Wolfram at 0.2905. Oh yeah, the function has a 0 when x equals a half, so yeah, for sure, since there's a positive piece to it. Yeah, it shouldn't be this bad. I do agree with that, vegans. So like the thing that you put, it only has x times x minus a half, which is way easier to work with. Why is, oh yeah, never mind, that's just, okay. That's a good point. Why do we get to ignore the other points that were given? I don't really know that part. But if we just took it at its word and just worked with that as our polynomial, I don't understand why, but if we just got rid of the stuff in the middle and only maximized that, that'd be a lot easier. So parabola facing down, it's not going to be the endpoints. Didn't I do this calculation in my head at some point? X equals a quarter that has a maximum. Maybe a quarter. What was the maximum for the entire thing? Let me look quickly. It was 0.29, which is kind of close to a quarter. But, well, we don't. So like in theory, we would just take, okay, I guess I'm having the same issue as you then, vegans. We're expecting to multiply the thing that we just got, pi squared over 4. Yeah, exactly, 1 over 16. But we need 576. Well, so pi to the 4th over 16 is greater than pi to the 4th over 576. Well, that doesn't help, no. Never mind. Even the thing that I did with the x equals 0.29, if you do the entire polynomial, that's still not going to be big enough. This feels like something I should be able to understand. I don't know why we're getting a different answer. Yeah, I don't know. I think with the 5th derivative set it equal to 0. Oh, to maximize the original function? That'd be the safe thing to do. Let's figure out what the 5th derivative is quick, and we'll form alpha. figure out where it's 0. Cosine derives to negative sign, so the negative goes away. Like that. X equals n over 2, where n is any integer, so there's extreme points at 0 and a half. That's what we said, though. No, I think that gives us the same conclusion that we already had. Because we already took x equals a half, and we got positive 8 pi to the 4th. There's no way it's this, but what if the trig identity has something weird and you're supposed to use the original sign version? There's no way this is it. It's going to be really annoying to calculate that derivative. I don't think that's it. It shouldn't be an issue with the identity. Yeah, sorry, I don't think... I guess I agree with you in the answer that you got. I don't know how we get the answer that the book is saying. I assume there's something that I'm missing, but I don't know. It's a hard problem. Whew. Yeah, all right. Well, I tried to help, but if you did something wrong, I can't spot the error. So thanks for trying, but with me. But I'm gonna go back to the real mouse stuff because I'm not sure. Oh my god, I'm tired. 1 is greater than 0. Yeah, vegans. No worries. I wish I could figure it out, but I guess it is what it is. No, that problem conquered me, Ben. Either the book made a mistake, or me and vegans were both making the same mistake, and I can't really figure out which one it is. Do you need a PhD? Apparently I do. Got a blackout again? Oh, that sucks. The delta law? Triangle inequality? What is the delta law? On a different website. Hmm. Um, every convergent is Cauchy. That's the direction that I was able to do. Maybe I do. I think I do have to go back to that proof that I didn't like, because everything else is saying it in a more advanced context. Okay. Let's look at if a sub n is Cauchy, then a sub n is bounded. Since a sub n forms a Cauchy sequence, then epsilon equals 1, for epsilon equals 1, there exists an n belongs to n such that this is true. Okay. In particular, a sub n minus a sub big N is less than 1. Do we know that? Oh, I guess m is greater than or equal to n. Okay. Which is in line with the definition of a Cauchy sequence. Okay. So here we're saying m equals big N. Hence, if n is greater than or equal to big N, then a sub n is less than or equal to absolute value a sub little n minus a sub big N plus a sub big N. Since this piece is less than 1, we go to this step. Let m be the max, a1, a2, da da da, a sub n minus 1, to 1 plus a sub n. This revolution. Yeah, you gotta do things the way that Newton did them. So a sub n is less than whatever the max of all of these are. And if it's an increasing sequence, then we'll hit this 1 plus a sub big N term. If it's decreasing, we'll just hit like a sub 1. Or if it fluctuates, then it'll be something in the middle. But if it is decreasing, and a sub 1 is our max, aren't we just showing it's bounded from above? I guess it's the absolute value. Well, actually, for this definition of bounded, I guess that makes sense, because if you take out the absolute value, you have negative m is less than or equal to a sub n is less than or equal to positive m, which means that's bounded above and below. So even if it's decreasing, you can still find the infimum. I guess that makes sense. Okay, I guess this is, I'm okay with this. I think I skipped over this proof last time I looked at this page, so this is the proof that I was looking at, and I was getting a little confused with how they were calling some of the letters here. So I want to look back at this one again. If a sub n is a Cauchy sequence, then a sub n is convergent. Let a sub n sub k be a monotone sequence of the Cauchy sequence a sub n. Then a sub n sub k is a bounded monotone sequence. We know it's bounded from this lemma, and we know it's monotone by construction. And we know a monotone subsequence exists it must have to exist at a certain point by it being a Cauchy sequence, I would think. What is the most straightforward way to prove that any finite set has a maximum? Do you use induction? I don't know what that would be, SPQ. Are you asking me that as a leading question, or are you actually like curious about it? Hey, star SK, that link isn't gonna work for me. That's like a file on your computer. Can you maybe type out the question in chat there? You just thought about it? Oh, okay. Yeah, I don't really know. That seems like maybe an axiom thing, SPQ, or I'm not sure. So must be the maximum, I guess. But how do you know the order of the set? I don't know. I don't know how you make a counterexample. Okay, stars. Okay, so what is the value of 2.6 plus 0.5 times 1 3/4 minus 3/2? The proof is trivial. Perfect. All right, so stars. Okay, I'm going to write down what you've typed and hopefully and tell me if I'm interpreting you right. Or tell me if I'm getting something wrong. Okay. So you're saying what is the value of 2.6 plus 0.5, and then in parentheses 1 3/4, so multiplication, minus 3/2. This is kind of like a mean problem because we're mixing notation. That's probably the point of it though. So does this look right, star SK? Yes? Okay. So I would get everything as decimals or everything as fractions here. Decimals looks a little bit easier to me. So let's do that. So 2.6 is already a decimal, so let's keep that how it is. 0.5 is also decimal, so let's keep that how it is. 1 3/4 is 1.75. Because there's a couple of ways that you could figure that out. I just kind of do it intuitively knowing that 3/4 is 0.75. If you don't know that, or if you're given a harder fraction, the trick that you can do, you want to convert it to an improper fraction. The answer has to be in fractions? Oh gosh, okay, let's get everything in fractions then. Thank you for telling me that. Okay. So 2.6 is a fraction. There's a couple ways that we can do this. I'll get everything as mixed numbers, I guess, and we'll get into improper fractions in the next step. So 2.6 is the same thing as 2 and 6/10. That's 16. Because there's only one decimal there, you take that and just divide it by 10. If there's two decimals, 2.66, you do 66/100. If there's 3, you do over 1,000, and so on like that. 0.5 is just 5/10. Same rule here, 5 the number 10. Pro Moment 69, thanks for the follow. And then I'm just gonna keep 1 3/4 as the same thing for now. And 3/2 is, I'll keep the same thing. Okay, so how's it going, Pro Moment? Do you know calculus well? Yeah. If you have a question, feel free to type it out in chat. So, Starscape, now the next problem is that I want everything to be in improper fractions. These mixed numbers are kind of hard to do math with. And the trick to, an inner question? Yeah, that sounds fun. The trick to convert a fraction, a mixed number like that, into an improper fraction is you do the denominator 10 times 2 plus 6. So times and plus. So 10 times 2 is 20, plus 6 is 26. And the denominator stays the same, so 26/10. Then 5/10. Same trick here, 4 times 1 is 4, plus 3 is 7. 7/4 minus 3/2. Oh, and problem is if it's easier to post a picture or a screenshot, I do have a Discord as well where you can do that. Now let's do some fraction math. 26 over 10, you can reduce that. There's a common factor of 2 here. So we can cancel out a 2. That becomes 13, that becomes 5. So 13 over 5. 5 over 10 also cancels. That's 1 over 2. We can also do the multiplication here. So when we multiply across the top and then across the bottom. So 1 times 7 is 7. 2 times 4 is 8. Oops. And the 3 over 2 can stay the same. Post the pick? Okay, so sounds good for a moment. All right, so now we take a common denominator here. I'm going to work on these last two fractions first because I think they're a little bit easier to work with for me because 2 and 8 have an easy common denominator. I'm going to multiply this by 4 over 4, which is the same thing as multiplying by 1 because we want them to both have an 8 on the bottom. And 2 times 4 is 8, so then we'll be able to do math there. 7 over 8 minus 3 times 4 is 12. 2 times 4 is 8. Now these have the same denominator, so we're allowed to subtract the numerators. 7 minus 12 is negative 5, so we get minus 5 over 8. And just now, one more line. We've got a common denominator with 8 and 5. The easiest number to do that with is 40. So we'll multiply this by 5 over 5, and that by 8 over 8. So 8 times 13, oh god. That's 80 plus 24 is 104. Over 40, because 8 times 5 is 40. And then 5 times 5 is 25. Over 8 times 5 is 40 again. Now we can subtract across the numerators. 104 minus 25 is 79 over 40. Yeah. So can you make that a mixed fraction? Yes. So if we make it a mixed fraction, just do division here. So 79 divided by 40, set it up like this. 40 goes into 79 once. Then you do 40 minus, or 79 minus 40 is 39. So you have a remainder 39. So that means your mixed number is 1 and 39 over 40. Your denominator stays the same. Hopefully that's one of the possible answers. Oh gosh. Look at that integral. It is? Okay, great. Glad to help. All right, let's look at Perlman's problem. This is an improper integral. Having a problem doing the limits and such. Could you solve it? Okay, so it's improper because we have a discontinuity at x equals 4, smack in the middle of this interval. How do you actually, I don't know how you can actually integrate this. Oh wait, no, oh, it's not that bad to integrate. Okay, so yeah, I can definitely do this. So with these problems with the discontinuities, I get a little bit lazy and I tend to make my notation a bit simpler. It's technically bad form though. And I'll show you what I mean in a minute. Okay. So, oops, let's get rid of the cam. Let's consider the integral from 1 to 6 of 5 over cube root 2x minus 4 to the 5th dx. Okay, so the discontinuity here is when the denominator is equal to 0, which is when x equals 4, and 4 is between 1 and 6. So that's the reason why this is an improper integral, as you said. And how we account for there being an improper integral is when it's in the middle of the interval, you have to split it out into two separate ones. So, and limits are involved. One integral is going to be from the limit from 1 up to 4, but actually we're not going to write 4 there. We're going to use a dummy variable t. As t approaches 4 from the left of the same thing, plus now the other part of the integral from 4 up to 6. And I'm going to use, yeah, we're allowed to use t again, I think. Now we go from t up to 6. And notice this is 4 from the right now, because we're going basically between 4 and 6, so we're going to 4 from the right side. There we go. Shouldn't t approach 2? There's, oh my god. Thank you for that catch. I don't know, I made that 4 into an 8 in my head. You are completely right though. Thank you for telling me that. Yeah, it's 2. The discontinuity is at x equals 2. I don't know why I made that. Or maybe, I don't know why. I guess because I saw the 4 there and I was like, oh, 4. Yeah, you're right. The discontinuity is at x equals 2. Okay, so technically, now you should do these two integrals separately and like side by side. I tend to just drop the bounds entirely and figure out like the integral in a vacuum. Like I'll just work on this problem so I don't have to keep on writing the limit at every single step. That's what I mean by getting lazy and with my notation, but I'll do it out the long way just so it's like the proper way. Normally I would just like boil down to this problem though and work on this and then worry about the bounds at the very end. But I don't know if you're technically supposed to do that or if you're or what. So this way that I definitely know will work. Okay, sorry, I can work on that after this. That's also how you usually do them? Okay, if that's how you usually do them too, then let's do it like that. And then we can come back up to this step later once we know what the indefinite integral is. So the first thing I do is rewrite this whole cube root to the 5th power business as one single fractional power. And because it's in the denominator, we can bring it up to the top and make the power negative. To the minus 5 over 3 dx. One second. I feel like I recognize this song. Is it from Spirited Away? It is. Okay. So this is going to be, to integrate this, we do a u sub. Du equals to dx. There we go, like that. Now this is just a power rule. So add 1 to the power and then multiply by the new power. No, you divide by the new power. So that becomes negative 2/3. So you multiply by 3/2. I need to like do this back just to make sure, but 5/2 times 3/2 is 15/4. Then if you derived it back, you multiply by 2/3. And you get 5/2. Okay, good. Now we can unsub. Technically plus c, but we're not going to need the plus c because we're doing definite integrals up there. So now we can use this as our answer up here and here, aside from the limits. So let's come over here and say this integral it's the same as limit as t approaches 2 from the left of that evaluated from 1 to t, plus then this integral is basically the same thing. And I didn't plan out my space very well here. T to 6. Okay. This limit is a little bit annoying to get, isn't it? Does this integral diverge? We're getting 1/0 in the limit. I want to confirm it, but I feel like we're going to get infinity when we approach 2 here. Or negative infinity, I guess. Oh, wait. Yeah, we have a square root. We can't... Did I mess with power? Oh no, we have a cube root. We should... Did I do something wrong? Or Malfa puts it in a weird way. Is that the same thing? They would have canceled a 2 out for... Yeah. I'm trying to figure out if my answer is equivalent or not. I think it should be 15 over 4. Or I think... Two. I think okay, no, I think it's the same thing. If you multiply this fraction by 2 over 2, and then you cancel the 2x minus 4, 2x minus 4, I think you get the same thing that I got. Okay. And so just visually, this function does like blow up to infinity at x equals 2. So okay, yeah, so, thank you for subbing, Star. We're almost towards the end of this problem here, so I'll look at yours after this. So yeah, okay, so like I thought, I think my answer is right, as I wrote on the board. Even though Wolfram Alpha looks different, I think it's the same thing. And already with this one, I can even rewrite it. Limit st approaches 2 from the left, minus 15 over 4 times 1 over 4 to the minus 2/3 to t, plus, and I'm just going to do dot, dot, dot for that. So like this already, we get the limit as t approaches 2 from the left here, and this blows up to positive infinity. Or, you know, when you're basically dividing by 0 for the sake of the limit, which means you end up with infinity. This one becomes infinity, there's a negative sign, so I guess you turn it into negative infinity or something, but we're pushing 2 from the left, so it's going to be positive infinity. Either way, you get infinity, and when you get infinity with an improper integral, you just say the whole thing diverges. You don't have to do any other work. I guess you need to get an infinity in one piece of this integral, the entire thing just diverges. So the answer is that it's divergent, I think. You have to demonstrate it. I guess how rigorously? Because I would say that, like, from this we got positive infinity, because that part down there is negative, and there's a negative sign out there. Then you plug in 1. Oops, that's not a negative exponent anymore. Like, you have to actually do limits step by step. For me, that is doing limits step by step, to be honest. I don't know how much, like, you need to do an actual proof, like epsilon delta type of thing. Well, I guess when it diverges, I don't know if you even use epsilon delta. I guess in the calculus class that I took, you wouldn't have to do the limit. You wouldn't have to justify it any more than that. So I guess I'm curious, like, what a justification would look like in your class. Your professor would take points if you didn't do the limit from x all the way till the end. It's weird, actually, now that you mention it. Really? Yeah, I don't know how else you justify it in the context of a normal calculus class. Like, I'm sure there is some kind of, like, proof way that you can show the limit goes to infinity. I don't really know how. I never learned that part, to be honest, for myself. if you can send me maybe an example of a similar problem, I could probably follow it along. But I'm kind of curious, like, what more your professor would want there. And Star SK, I stream on Tuesdays, Thursdays, and Saturdays, starting 4 hours and 15 minutes ago, whatever that is in your time zone. Basically at 1 p.m. Pacific time. If it was convergent, he would just add the two limits. Yes. Or if it was convergent, you would just, you know, do limit, whatever it comes out to be, subtract the lower bound 1, and then plus whatever that limit comes out to be, or, you know, plus 6 with, and then subtract out whatever the lower limit comes out to be. So yeah, Perlman, I'm sorry, but I don't know, like, how to explain the last part to you, I guess, with the, saying more about the limit other than it diverges from the step that I did it, but I hope this helps a little bit. I'll keep the problem up on the board in case you type anything else, but for now I'll look at Star SK's inequality. All right, so Star SK, you have the inequality minus 2x plus 3y is greater than 10. Greater than or equal to 10. Okay. So the way that I was taught to do these and the way that I like to do them is drawing a line on an actual graph. Oh, okay. That was the or equal to part. So are you comfortable with graphing a line? Like if you had minus 2x plus 3y equals 10, would you know how to graph that with your x and y axes? Yeah, okay. So for the first part of this problem, I want to do exactly that, pretend it's equal to, and get a graph of this line. Well, actually, there's different ways to go about this. So it's another multiple choice question. Are the answers in the format like y is greater than or equal to something? Like what kind of format are the answers in? Because we might actually need the graph here. I was to answer the question in general, but you might be able to just do some algebra and not have to graph the function in the first place. No? Are the choices 3, 5? Oh. Interesting. Okay. So we can throw all this out. We need to just can you tell me what all the possible, or I can tell you like how to do it, but we need to take the possible the possible answers that they give and just plug them in. So 3, 5, for example. 3 is x and 5 is y, so we're just going to plug those right in. So minus 2 times 5 plus 3. Sorry, I said x is 3. Plus 3 times y, which was 5, is greater than or equal to 10. And we're going to check if this is a true statement. Okay, thanks for giving all the points. So negative 2 times 3 is negative 6. 3 times 5 is 15. Greater than or equal to 10. -6 plus 15 is 9. This statement is not true. 9 is not greater than or equal to 10, so it can't be that point. Maybe the x is confusing. So 3, 5 does not work. And this is a process that we're going to have to go through for all 3 of these points, or all 4 of these points until we find one that works, unfortunately. Can I just tell visually if one of them is going to work? Oh, I'm getting 2 of them are going to work. Maybe oh, you get it? Okay, so do you want to see me like go through and do them all, or do you know what to do and you can do it on your own? And honestly, the second and the third choices both seem to work for me. All that applies. Oh, okay, good. That makes a lot more sense. All possible answers. Okay. So yeah, I just did it mentally. It should be the second and the third ones. But yeah, if you get how to do it, then I'll just like leave you to it, I guess. If you have another question, please let me know. Improvement, same for you if you have another one. I'm sorry that even though I couldn't explain that last part, but I haven't seen you type in a minute, so I'm going to erase the problem that we were just working on. You give me, okay, sounds good. Was it the wrong solution? Okay. Okay, so we have the integral from 0 to 5 of 1 over x to the 5th dx, and we have a discontinuity at x equals 0. So that's something we're going to have to deal with the integral. I do like the little icon with the guy slipping. Okay. Limit as t approaches 0 from the right, from t to 5. This step looks good to me. Integrate it, so you add 1, then divide by the new exponent. Still looks good. You guys falling for mistakes? Yeah. Oh, is this what we mean with showing why the limit? Oh, I could have done like this. Oh, that's my bad for misunderstanding you. This is a little bit annoying, but it could be worse, I guess. Oh, I see the mistake. They say that 0 to the -4 is equal to 0, but that 0 is actually in the denominator because it's a negative exponent. So you're actually dividing by 0, so you'll get negative 0.004 minus infinity. That's actually plus infinity because it's minus negative 4. But yeah, it's this interpretation of 0 to the negative 4. It's actually infinity. So this integral should diverge. And just to, convince ourselves even more, we could look at the actual function that we get as a result of the integral. Like that. And so we're going 0 from the right up to 5. So yeah, we get negative infinity when we go from 0 to 5. So what you meant? Oh, okay. I tried my inverse of 0 and just follow me. Does that make sense for where the error is in this like solution though? Right. Diverges too. Here's 0 is infinity. QED, I like it. If you get 95% on your test, your overall mark will be 90%. Oh, nice. Well, good luck. You said it's tomorrow? On Monday. Okay. So you got some time. Complex analysis. There's only one infinity? Is infinity times I not like significantly different? I guess it's still infinity. I think there should be an imaginary infinity. And just to be really obnoxious with writing it out, you have to like draw the infinities with eyes. Like, this is imaginary infinity. I can't even figure out how you draw like that. You have to make an infinity with the letter I. There's minus. Oh, okay, that makes sense. I guess a negative infinity doesn't have as much meaning with complex numbers. Oh, Frylock, yeah. Sorry, I saw that, but I was like thinking about the math. Favorite show? I think The Office. Oh, Star, yeah, this is calculus that's on the screen right now. I would not expect you to get this. I wouldn't feel bad about it. But yeah, Star or Perlman, if either of you have more questions, please like let them rip. But derivatives also hard for you? Okay. Star just posted their question, so I'll do that one first. R wood? Oh, okay. Simon uses the slippers, which are each 30 centimeters long, to measure the length of a wall in his home. Simon sounds a little weird, but okay. This wall is 15 slipper lengths long. What is its length in meters? Okay. It's kind of a goofy problem, but we can do it. Now, I'm American, and I feel threatened by the use of centimeters, but I'll try to get over that. So Simon's slippers are 30 centimeters long. So I like to do these unit problems. Well, No, let's figure out the length first. So if it's 15 slipper lengths long, which is a weird unit that sounds like a unit that America would use actually. We have 15 slipper lengths as our unit times each slipper is 30 centimeters. So 15 times 30 is 450 centimeters. And this is, so that's length of the wall in centimeters, but there's a bit of a trick question here because they ask for the length in meters. And so let's convert 450 centimeters into meters. And if I'm not being too stupid, centi is 100. So is that 4.5 meters? If I'm getting my conversion right. And the trick to converting stuff to is you can do 450 cm and multiply it by, there's 1 meter, or for every 1 meter, I think you have 100 centimeters. I was getting tripped on whether it's 100 or 1,000 to be honest, but I'm pretty sure it's 100. Cm and cm cancel out. You want to set the fraction so that you get that cancellation. So 450 divided by 100 is 4.5, and then meters are left over. So I think your answer is 4.5. That's a choice? Okay, good. Yeah, I'd say it's 4.5. Metric system for the new California Republic. Problem, I don't see a problem from you. No worries if you're still working on it. And get this erased. God of War? No, I haven't. All right, so problem or star, unless I see another problem from either of you, I'm going to go back to looking at just some things that I was studying for myself. But if something comes up, please let me know. Oh, okay. Null growth address set? I'd never heard of that. You could try posting the original Spanish and I might be able to figure it out. Well, I have played Red Dead Redemption. Conjunto de direcciones de crecimiento nulo. Let me try Googling that and seeing if something interesting comes up. Or something that I recognize. Crecimiento nulo. Perpendicular derivative. Yes, star, that's completely fine. I'll like download something on my computer. Ugh. Perpendicular in a derivative that tells you where it's not vary. Okay, so maybe that might just be the tangent line with zero slope. Let me like draw a little picture. Like if you have a function like that, it's like the line that goes like horizontally with zero slope. Okay, yeah. We can definitely, or I know how to find those. Basically, like a critical point is the way that we might say it in English. Or extremum. And yes, PQ, I think you're right. You're just saying it in the more advanced way. So yeah, if there's a function you need to find those points for, I can help with that. In the meantime, I see Star posted another word problem multiple choice. The equatorial radius of Venus is 78.5% greater than that of Mars. The equatorial radius of Earth is 5.3% greater than that of Venus. If the equatorial radius of Mars is 3,000, oh gosh. I'm gonna copy paste this over into like the Twitch chat too, just so like if someone wants to correct me, they can do it. Okay, it's like they're just making you work with percents and making you do a lot of extra work. Okay, so so for equatorial radius of Venus, I'm just gonna the power back at 0% charge. Oh, nice, that's clutch. Like when your phone is at 0%. Okay, so let's start from what we're given. The equatorial radius of Mars is 3,389.5. We want to get Earth, but we're only given things in terms of Venus because they want to make us do work. So the equatorial radius of Venus is 78.5% greater than that of Mars. So we want to get the radius of Venus. So we need to increase that by 78.5%. And so when I do a percent increase, I do 1 plus the percent as a decimal. So 78.5%, you convert it to a decimal by moving the decimal to the left twice. So it's equal to 0.785. So we're going to do 1 plus 0.785 here. And we need a calculator for this. That's definitely not mental math. It's your genius. Yeah, sure, per moment. Okay, we get 60, 50. I guess we can round off at 1 decimal, 0.3. We might get an answer that's very slightly off if they rounded different, but let's just round off at 1 decimal. So 60, 50.3. And just to keep track of where things are coming from, that was Mars. This is Venus. Now we want to get Earth. So we know Earth in terms of Venus. So Venus is 60, 50.3. And, oops, the camera. Equatorial radius of Earth is 5.3% greater than Venus. So Earth is 5.3% greater. Okay, let's be careful with the wording here. Earth is 5.3%. I know why I'm doing a lowercase, but it's fine. So when we translate this, 5.3% greater than Venus. That's a 5.3% increase from Venus. Yeah, the wording is very weird. Earth is bigger than Venus, I know that much, so... Yeah, so... what I was going to do here, which is still valid, is set up the same equation, but if we like put it in this phrasing, the is an equal sign. Earth is whatever we're going to get for our result. 5.3% greater than turns into our 1 plus 0.053, doing that same decimal trick. And then Venus is whatever we got from before. I think that's how we dissect these words here. A 5.3% increase of Venus's radius is where you get Earth. So let's see what that is. So 6370.9, or I guess 6371.0 maybe. And equatorial radius of Earth. 6378. Is that what I got? 6371? Maybe because of the rounding, that's pretty close. Besides Fall, Dark Souls. So do you have 6371.0 as an answer for how, I guess that's how you would round it? Okay, I would go with that then. Given those functions, operate the function in the derivative of. Dadas las funciones f of uv equals u to the v, u of rs equals r squared plus s, v of rt equals r cubed t. Calculate the function f of rst in the derivative. Okay, we can do this for sure. And you're right, this one, even if I didn't know what Spanish was saying, I would get the idea. Oops. Okay. Yes. Exactly that is how we should do this problem. So we know that f of uv is u to the v. U of rs is r squared plus s. V of rt. Are we gonna need v? Oh yeah, duh. R cubed t. Okay, so just make sure I'm not missing anything, but yeah, since u is a function of r and s, and v is a function of r and t, we can get f of rst. Since we know that u is r squared plus s, we know that v is r cubed t. And so I assume that wasn't the hard part. The harder part was getting the partial derivative here. So when you do a partial derivative, we want the f dr. Okay. When you do a partial derivative in terms of r is the only variable we care about. T and s we treat like constants, like their number, like 2 or 3 or whatever number you want, for the sake of doing this derivative. So this is kind of mean. This is like the situation if you have d by dx of x to the power of x, if you've seen that problem before. Because we have r to the power of r here. And so there's a trick that we have to use. If we have this situation, we need to rewrite it as e to the power of x ln x. And that is something that we know how to derive. And e to the, and this is like, these are completely equivalent, x to the x and e to the x ln x, because the e and the ln like cancel. So we're gonna do the same thing as this, but for this slightly more complicated thing up here. So we're going to do of e to the original exponent, r cubed t, times ln of the base r squared plus s. This and this are the exact same thing, just rewritten slightly, and this is something that we know how to derive. Let me get rid of this so I have some more space. So when we do the partial in terms of r here, e just derives to itself, so let's write that. r cubed t ln r squared plus s. Now we have to do the chain rule up here. So let me get some brackets. So we have to derive this as our chain rule, and this has a product rule and another chain rule inside that. I might need some extra room here. Okay, now for chain rule, we have to derive this thing. So we have a product rule with r cubed t times ln r squared plus s. I'm going to start by deriving r cubed t. That's 3r squared t ln r squared plus s. Plus, now we derive the ln. So the r cubed t will stay the same from there to there. Now we derive the ln, that's 1 over whatever's inside. But what's inside has another chain rule, so r squared derives to 2r. Okay. There's some simplifications that we can do here. I'm going to write this part first just because it looks a little bit cleaner to me if you do it that way. It doesn't really matter though. R cubed t times 2r is 2r to the 4th t over r squared plus s. Close that. E to the r cubed. Oh, and actually, e to the r cubed t can, we can cancel the e and the ln again. So we get r squared plus s to the power of r cubed t. See, there's more that you could do to it, but I would call this the partial, I think. Please repeat the last part. Oh, shoot, I didn't see when you wrote that. Which line do you want me to explain? Like the last line, the second to last line, third to last, or? Just now? Oh, okay. So yeah, the very last thing I said was like the e and the ln will cancel again. And so the r squared plus s can come down. The r cubed t stays up top in the exponent. That was like the very last step that I said. Because if you have e to the x ln x, the e and the ln basically cancel, so that x comes down, and you get x to the x, because that x stays there. It's a little bit of a weird thing. Yeah. It's a kind of a mean... Oh, wait. We're not done yet. Yes. We have to plug in 125 for R, S, and T. Forgot about that. Well, I mean, I'll show it, but I assume that's something that you know how to do too. df dr evaluated at 125. Okay, so that's RST. So that's 3 plus ln 1 plus 2 is 3. 2 times 1 times 5 is 10 over 3. 3 to the 5. So we get 3 to the 6 plus 3 to the 5, ln 3 plus 10 times 3 to the 4. 3 to the 6. It's not mental math for me. $729. I mean, plus 10 times 3 to the 4. 1539. So we get 1539 plus 243 ln 3. Not the cleanest answer, but I think that's your answer. Okay, and then let me know if there's anything about that that I didn't explain well. I wouldn't be surprised. Star is saying the volume of the square-based pyramid shown below is given by v equals 1/3 base squared times height. Select all the changes that would result in a pyramid with 4 times the volume. So first choice, multiply side length of the square base by 4. That one's not going to work, and I'll show why. V equals 1/3 base squared times height. So the first choice, we have v equals 1/3, parentheses, importantly, the side of the square base multiplying it by 4 means we basically get 4 times b in parentheses cubed h. Oops, not cubed, squared. And how we interpret this is we get 1/3, and the squared goes to the 4, and the squared goes to the b. So 16b squared h, because 4 squared is 16. So this is actually 16 times our original volume, whatever our original volume was. If you can write that even clearer if I bring the 16 out front. 1/3 base squared height. So like we have our original volume here, but times 16. So that's not... Yeah, no worries, pro moment. So the first choice does not work because it's 16 times the volume rather than 4 times the volume. Second choice, double the pyramid's height and double the side length. Doing the mental math, that's not going to work, and I'll show you why. One third. So doubling is the same as multiplying by 2. So we're doubling the base and we're doubling the height. And so here, let's do the same exercise. 1/3 times, I keep on mixing my notation. 2 squared is 4 times b squared times 2h. Bring all the, we want to get the original kind of 1/3 b squared h on its own. So let's bring the 4 out, let's bring the 2 out. 2 times 4 is 8. So we get 8 times 1/3 b squared h. So that's 8 times our original volume. That's also bad. So start, does this like process make sense to you so far? I can show for the third one as well. One third, now we're multiplying the height by 4. So b squared times 4h. Now we can bring the 4 out front and we get 4 times a third b squared h. That one's a winner because now that's 4 times our original thing. It makes sense? Okay. So plugging in the formula, exactly. There's one more there. I'll tell you that it should work, but I'll leave the math part to you if you want to try that. It'd be a good one to try and make sure that you get it. Yeah, you basically plug things in and then bring all the extra numbers out to the front and see how it's different. No problem. Okay. Oh. Let's get our Firefox back up. Oh, I scaled this up. Some nice problems, and we do this for another half hour or so, so it's about time for more questions. In the meantime, I'll fill in with what I've been filling in with. Looking at Cauchy sequences, trying to understand them for myself. Okay, so I just looked at this proof, and I felt comfortable enough with it to move on to re-review this proof. I think I was partway through this. So let a sub n sub k be monotone subsequence of the Cauchy sequence a sub n when a sub n sub k is a bounded monotone sequence, right? Hence a sub n sub k converges to L. Let's just call that. Now when the sequence a sub n itself converges to L, let epsilon be greater than 0. Choose n sub 1 and n sub 2 such that n comma n sub k is greater than n1, where this first n refers to the original sequence a sub n, and the n sub k refers to the subsequence that we've chosen. We'll take values of them both that are greater than n1, which would imply that a sub n minus a sub n sub k is less than epsilon over 2, which the epsilon over is a little bit arbitrary, but it gives us a nice thing in the end. And we also choose and if we choose an n sub k that's greater than n2, that implies that a sub n sub k minus a, which I'm interpreting as L, is also less than epsilon over 2 just by the definition of a limit. No? Yes. This first one's definition of a Cauchy sequence, the second one's definition of a limit, because we have established that a sub n sub k has a limit. Then n comma n sub k is greater than the max of n comma n1, which I'm interpreting this as a typo for n1 comma n2, unless I'm misunderstanding something. But basically, whatever our n1 and n2 are, let's just take the bigger ones so we know it works for both of these statements simultaneously. This implies that a sub n minus a, or L, they do plus or minus a sub n sub k, and then apply triangle inequality. So that's what this step is less than epsilon. Oh yeah, because we've added, oh yeah, so they do triangle inequality here. And we know the sum of these two is less than epsilon. Now, you know what I'm just realizing? I don't really get how this shows the claim that the original sequence also converges. Well, I guess that just means a sub n is very close to a sub n sub k. Okay. And star, let's see what you just wrote. During the month of April, a clothing store offers 15% off the original price of all sweaters. In May, the store offers an additional 20% discount on the April price. What is the final sale price of a sweater that had an original price of $44.99? Now, there's two different ways to interpret this question. And both are valid, unfortunately. I think what they want you to do is what I'll show you first. So the original sales price, or the original price, is $44.99. And if you're getting, let's worry about the first discount of 15%. So if you discount something by 15%, you're multiplying the original by 1 minus 0.15. That's something that that's something that I just kind of remember, to be honest. Because if it's 15% off, it is 88% of its original price, or 85. And sorry, I'll write my multiplication with x's. So the sales price after the 15% discount is whatever that comes out to be. I'll plug it into a calculator quickly. $38.24, we'll call it. Got to round it a bit. That's the 15% off discount. So now there's an additional 20% discount. So let's take this and do the same exact formula. One minus 20% now. So 38.24 times 0.8. Let's see what that is for the benefit of a calculator. $30.59. So I would say that that's probably your answer there, star. But there's a complete other interpretation. So this is called like multiplicative scaling, I think, or something like that. But you could also interpret their question as just you add 15 and 20 as a 35% discount. I don't think that's what they're trying to say with this question, but this is different from a 35% discount. The 35 discount is better, I think. You get a lower price. So I'll show it just so you know it exists. I think the point of the question is the first interpretation, but know that they are different. And sometimes you want one and sometimes you want the other. 3059 is there. I would call that your answer. If it was a straight 35% discount from adding them together, you would get 2943. Or sorry, 2924. So the question isn't worded clearly enough to me to make me certain it's one or the other, but I'm pretty sure it's the first one. It's like doing 2 discounts in a row. That's an answer too? Oh my god. I would go with 3059. That's my instinct, but that may be one to ask the teacher about, or maybe there's something the way that you were taught. This is something that it depends on the class, unfortunately. Oh, I'm sorry that happened quite a lot, but glad it cheered you up a bit. So yeah, I wish I gave a better answer, star, but the question could be clearer, I guess. Or could be written more clearly. Just making sure I'm not missing any questions. Okay. All right, back to Koshi. Oh, it's not because this is less than epsilon, it's because this is less than epsilon has shown that a sub n converges to the same limit as a sub n sub k. Okay. is reflected in the x-axis. Okay, so the line y equals negative 5x plus 4 is reflected in the x-axis. I think I know how you do this off the top of my head. Let me just verify. What are the coordinates of the y-intercept? Ooh, interesting. Okay, I'm not saying the exact thing that I wanted them to say, but I think I know the idea here. Okay, so we have the line y equals negative 5x plus 4. So first off, we want to reflect this across the x-axis. And so if you reflect across the x-axis, it's the same as making your y negative. So wherever we see y here, we write negative y instead. There's only one y there, so we'll write negative y here. And if it's a fraction across the y-axis, we do the reverse, where you make x negative. But it's across the x-axis, so we use our y's, even though it's kind of weird. But so now let's solve this again for y, just to get y isolated. So multiply everything through by negative 1. So negative 1 times negative y is positive y. Negative 1 times negative 5x is positive 5x. And negative 1 times positive 4 is negative 4. That's our new line. And we want to find the y-intercept of this new line, which is where x equals 0. So let's plug in x equals 0, and we get y equals negative 4. And that makes sense to me because our original equation had a y-intercept of positive 4. If we reflect it across the, let me actually show this. 5x plus 4 looks something like that, just very vaguely. And if you take this line and reflect it across the x-axis, it's going to look sorry, I'm having, it's going to look like that, I think. Having a little bit of trouble with the visualization, but it should look like that. I can actually graph it in an actual program that'll do this the right way. So they're saying y-intercept. Sorry that I missed that question first. The y-intercept is wherever the line meets the y-axis, and that's when x equals 0. On Saturdays, probably I do math. There we go. That's a bit more clear about. reflection across the x-axis. So our original y-intercept was 4, and then when that point 4 gets reflected across, it becomes -4. Do you know why coding is on? I don't actually know what EQAO is, to be honest. You have a lot of pseudocode questions. I bet I could figure those out. I don't think, as long as the pseudocode isn't like too tricky. No waifu poster. Hey, Michael. No. Oh yeah, I figured that EQA was it as an exam. You know, I figured that Michael, I can never have as many waifu posters as you do, and if I can't have the most, then why even try? You know. Yeah, sorry. If it's easier, you could post screenshots in my Discord too. There's the link there. It should pop up in a second. There it goes. Nightbot's a little bit slow on YouTube. So yeah, with Pseudocode, it might be easier to post like screenshots, so that's available to you too if you use Discord. Okay, yeah, looks like you hopped in. I'm not gonna be. I only have a few more minutes, so if there's something, I maybe have time for like one more star. But I'm gonna have to call the stream here pretty soon. It's not. I mean, you're saying it's pseudocode, but you can still post it in the math homework help one. In the meantime, it's not working. The picture isn't, or the Discord isn't. All right, see you, Frylock. If you only could try to copy paste the code, I just think it's going to be formatted. It's going to be hard to see the formatting. It says error when you try to send. Really? I'm not sure. It's hard for me to help in this case. You send it? Yeah, sorry. Oh, I see. Okay. Okay, see, we got two images here. Let me bring these up. I think this has to be my last problem. See you, Michael. Okay. Oh, I'm not cutting off the stream quite yet. I'm gonna do this last problem first, but if you guys are going, then see you to you guys. Or it's gonna be like another few minutes, I guess. And then I'm gonna read out to Zach. The following sequence begins with the numbers 0 and 1. Each following term is found by adding the previous two terms. Ah, okay, so this has a name called the Fibonacci sequence. That's not important, though, for the purposes here. Pseudocode will display the first 30 terms of the sequence. Draw an arrow to indicate where each line of code should be placed to correctly complete the pseudocode. Is value 1 equal to -1? Oh, gosh. Okay, let's work with this version. Okay, so shoot, I should have gotten this in Paint, so I can actually edit this. All right, give me 1 second. Okay. So, thankfully this one isn't too bad. So, on our first line here, we have set value 1 equal to -1. And then we have a blank box we have to fill in. None of these first two really make sense to me because they each involve something called value 2, and we haven't said what value 2 is yet until we get here to this third one that initializes value 2. So I would put this in the first box, because we need to say what value 2 is before we can do anything with it. And so now we loop 30 times. And we have the same issue. So if we look at the second one, we have set value 2 equal to next. We haven't said what next is, though. So it doesn't make sense to put the second one in this next box. But here we are saying what next is in the first box. Calculate next equal value 1 plus value 2. Let's put that here. We display next, and then we set value 1 equal to value 2. And then finally here, it makes sense to me to say set value 2 equals next. So in this case, we could just tell by the variable names where things should and shouldn't go. We don't even have to think about how the code actually works. We just, can go by the name of things for this particular question. Yep. So yeah, like I said, that's gonna be the last problem for me though, because I'm getting tired. Glad I was able to help you out, Star. If you have more questions, the next time we're streaming is Saturday, starting 5.5 hours ago, whatever that is for you. If you have more, but you'll do it next time? All right, sounds good. Remove that. Okay. So at this point, I am going to cut the stream off. But before we do, we'll send a raid on Twitch. We're going to go over and raid Zach. I can't raid from YouTube to Twitch, obviously. So I'm just going to do a shout out to Zach's stream over on Twitch in the real analysis class that he's been doing. Yeah, I hope that you have a good day too, Star. Thank you for the questions. And to anyone who's here, thank you as well, whether you're chatting or working. Back tomorrow with video games, and then the next math day will be Saturday. So yeah, see you YouTube.